Doing. Okay, perfect.
Good morning, everyone. Welcome to the Undergraduate Graduate School of Business. I'm Abigail Durant. I would just like your undivided attention for just about 2.5 minutes as I take your safety procedure. Feel free to ask me any questions at the end.
There.
Welcome to the Launchpad Graduate School of Business. Please pay attention to the following safety procedures and house rules. Reverse parking is mandatory. Parking or waiting in front of the main entrance of the building is prohibited. You are asked to pay special attention to the locations of the zebra crossings in the car park. If you are unsure about parking restrictions, our coach's security officers will be happy to assist you with your queries. Upon entering and exiting the building, all visitors are required to sign the logbook, which is located at the reception booth. Washrooms are located on the ground floor opposite the restaurant and on the first floor at the northern end of the building. Smoking is permitted in designated smoking areas only, and with the exception of bottled water, food and drinks are not allowed on the carpeted areas.
Oops.
There are emergency doors throughout the building that are clearly labeled. Please do not lean on these doors as the alarm will be activated and evacuation of the building will be mandatory. There are two muster points on the campus. Muster point 1 is located to the right of the security booth, and muster point 2 is located left of the security booth. In the event of an emergency, you will be directed to an appropriate muster point by safety wardens who are easily identified by their green reflective vests. These wardens are trained in CPR and basic first aid and will be available to administer assistance if necessary. Fire exits are clearly labeled and located to the east, west, north, and south of the building. The logbook will be used to account for all visitors on campus. Re-entry is allowed by facilities personnel after a thorough inspection is conducted and the building is declared safe. Our health and safety room is located on the first floor to the northern end of the building, and access is controlled by the designated safety wardens. Thank you for adhering to our policies, and do enjoy your stay at the Launchpad Graduate School of Business.
Any questions, anyone? Okay, enjoy.
Thank you. Didn't need the camera. Go in a second, let me.
So good morning, everyone. Good morning. Welcome to our first endeavor with this particular program that I'm going to explain a bit about. So let me hear everybody say good morning. How are we? Study for exams, I've heard some cases. Yes, how's that going? Good? Yes? Good. All right, so how many people know about this program? Did they research and know everything about this program? Yes, good university students. Very good. All right, so this particular program is called the Global Services Promotion Program. You can Google it and you'll see a lot of information about it online. Essentially, I'd like to keep things very brief and short. Our job is to attempt to use the ICT sector as a diversification tool. So, as you would have heard so many times over the years, it's a diversified economy. So one of this project's goals is to diversify the economy, but utilizing the ICT sector. And in particular, something called ITeS, which is Information Technology Enabled Services. Now, everyone knows what that means? No? Yes. So Information Technology Enabled Services are just as it sounds. So today you are doing software development and, I don't know, Microsoft Word and all those things, office productivity, accounting, all these things. And to a large extent, they use ICT to do it. Agreed? But it's not only those things that relate to ICT, you actually are doing. If you look at engineering, applications in plants, if you look at energy, the energy sector, if you look at even the gaming sector, you look at food and beverage and so on, they're all using technology in some way. It's particularly ICT to do what they're doing. And a byproduct of what they're doing is called IT-enabled services. So one of the things that the program is trying to latch on to is the concept of those services being made available and sold by people like yourselves, so that you can offer those services locally, regionally, and internationally. A snapshot of what the service might look like would be anything from, you've heard about the call center project that's going on in Tamina, software development, as all of you are obviously aware of, and things that I am very close to, things like data science and analytics. So anywhere along the spectrum of ICT, you can offer those services for fee. So one of the things that we want you to understand is that software development and what you traditionally do is not only ICT. That's not the only thing in ICT, and that's not the only thing you can do. So it's a good base to have. And one of the things we're going to do today is try and expose you to some deep thinking on the software development side, but also some broader thinking on what it means to be in ICT and ITeS sector. So this program is trying to bring that to many audiences, including students like yourselves, as well as the business sector. Tomorrow we have a group of ICT professionals who are currently working in the sector, and business owners who are owning those companies as well. So we have that happening tomorrow. You will not, and of course, it's going to be live streamed, so you can take a look at it. But today, focusing on the technical issues. This program also has a very big component of something called a hub, a Global Services Internationalization Hub. That building is located currently in Chabonas, and it's presently being geared to be outfitted to allow people like yourselves, when you graduate, to the building and actually start a business or continue a business and work for a business, depending on how you look at it. You can chat to me more about it afterwards. I don't want to take up too much time now, but that's pretty much we, as the government, we're trying to ensure that the sector is growing by providing facilities for people coming out of school to utilize after. They don't have to always want to come to work for, Infotech or Massey or Fujitsu. You can work for yourself, and you can probably work for yourself and make a very good living. But you need to understand how that works for you beyond the technical. I think some of the things we're going to discuss today might touch upon that, but also the program we're doing is to try and give you that grounding. So feel free to liaise with us. I have my colleagues in back in the room, Marianne Lamuta and Roxanne Coachers, who can also chat with you during the breaks and during lunch about what we're doing and how you can participate fully in the program thereafter. So I don't want to keep you too long, the time is of the essence. So I'll hand you over to Paco Soul Salmon. Yes?
I just want to raise, we do have a break available.
Yes, what time is the break?
About 10:30.
What time will it be available precisely? So we know.
We can shift it. It's available from 10.
10, okay. So it's between 10 and 10:30, right?
Okay.
Yeah, I mentioned that to them.
Perfect.
So Paco from Google, actually from Google, so we're not taking it. Antonio from Google as well, will be here to take you through today's activities through a series of labs. We encourage you to pay full attention. Please avoid browsing and doing your assignments, and I'm not sure exactly what you might be doing, but it'll be very useful to focus specifically on what we're doing here today, because this is not an easy task, and these people came from quite a far place to help you. So I appreciate your full attention. Right? I hope that I don't have any time for some of you, but please do close your laptops, put it away, focus on the lab screens, and let's have the labs with full attention. Thank you very much, and back.
Thanks, Tracy. Thank you, everyone. Please excuse my Spanglish. I will try to talk as clearly as possible, but if you have any doubts, please ask me. As you can see, we brought a bunch of content, And I wanted to give you a sense of what we are doing in general at Google, how we see the future in general of internet, technology. So I will try to focus on very different topics. The first one is to convince you about the mobile opportunity. You have been hearing about this everywhere. Mobile first, web responsive, Android, iOS, native apps. So I want to give you a very broad spectrum of why we are talking about this, why this makes sense. And I decided to start today with the mobile opportunity on web. Then I will move to Android and then to Firebase, which is the new Google platform to create mobile content for all of these platforms. Actually, and then we'll do a code lab on Firebase, and then we'll switch gears and we'll go to cloud technologies and machine learning, and then we'll do a second code lab on mobile vision. So please ask. I will try to go not as fast as probably I need to go because I have a bunch of content, but I will try and make sense of everything I'm saying. So in this first presentation, I will try to cover these 5 topics. The most important one, and probably the one I will devote the most time, is the number 4. Have you heard of these technologies? AMP, can you show your hands? Yeah, somebody? 2, thanks. PWA? Yes? Yes, progressive web apps, thank you. Okay, so we have an expert on the room, but I will try to go over all of these topics. So the first one. First, we have to understand, we are always talking about conversion. When you are planning on using technology for creating new apps or helping your business grow, being this probably a social environment or agricultural, it doesn't matter what you do with technology, you can always use it on your advantage. One thing we are seeing is that conversion, when you go to desktop, is higher. It's 3 times higher than conversion on mobile. Everybody is looking at their mobiles to browse for information, to search for stuff, compare products, decide what to buy or what to use. But in the end, when you decide, I want this thing, usually buying that from your mobile phone is very complicated. It's not as easy as you would like it to be. So this is the main problem we are trying to solve right now. And it's not only about selling stuff, it's about giving the user a great user experience. This is, I'm going to get you back in time. This is 2010, and the Wire magazine, which is one of the probably top technology outlets out there. This was the cover in 2010. They were pronouncing the mobile web as dead. It was the end for the mobile web as we knew it. And it made sense. Actually, it makes sense even now, a little bit, if you consider that most of the time when you are using your mobile, you are using native apps. Like 90% of the time, people is consuming native app content versus web. So if you think about this, this is a current number. Usually, when you get your phone out, if you have a smartphone, this is going to be the case. 90% of the time, it's going to be spent on native apps. However, these native apps have a couple of issues. The first one is that not everyone is using apps for a specific purpose. Most of the time is spent on social. Facebook, anyone? Social, Facebook, Twitter, etc., Instagram. And the other 20% is being spent on messaging, WhatsApp, things like that. And only a very small percentage is using actual apps for work or using information about your school, your work, whatever. So one of the problems we see is that the difference between mobile web and the native apps in terms of capabilities and the things you can actually do with the hardware and the and the gadget itself is very different. There's very little stuff you can do on mobile web, but we are trying to change that. So over time, the lifetime value, which is the value you get out of these users of your app or mobile web, it only gets bigger and bigger. The difference gets separated. This is the actual split I was telling you about. Social and messaging consumes most of the time users have on their phone. Entertainment, gaming, etc. It's also a huge consumer. So this is the real challenge. When you create an app, you want to have users going once and again to your app. In Google, we call this the toothbrush rule. If you get users to use at least a couple of times a day your app, then you're doing it right. If you're not getting there, the app is going to be just another one in the smartphone, and it's going to be deleted eventually. So that's not as easy. But if we start moving to 2016, we started seeing this trend towards mobile apps again, and people getting away from Android and iOS apps. And the problem is that every step you make the user, every time the user has to input data or do another click, you lose somebody, or you start losing a lot of people. So mobile first, the first lesson I want to give you is that mobile first does not mean native only. I will talk about Android and iOS, but it's not the only option. You can do mobile web effectively. And this is Wired, again, this is April 2016, so it's like 5 months ago. This was the new cover. And so they backtracked. It's a completely different editor. The editor from 2010 was let go. And now they are saying, hey, we're sorry, 2010, we were wrong. The mobile web is not dead. And we are getting back into mobile apps using web technologies. So winning in mobile is possible. If you are doing mobile web, it is possible, but we have to be aware of a couple of very important issues. So I'm going to concentrate in these 4 steps to create a great, amazing user experience in mobile. The first one, which is probably very easy to understand, if you only take one thing from this talk, is this: you need speed. If your app is really fast on mobile, even if it's ugly, even if it's not very cool, but if it's really fast, you have a chance. People is probably going to stick with your mobile site, and it's going to return. You have to make it really fast. How fast? How much do you wait when you click on a mobile site and the little thing starts spinning? How much time? Give how much you wait? How much? 3 milliseconds? Oh no, that's really too fast. No. Probably, yeah, you're very impatient, but maybe in seconds. How many seconds?
2 seconds.
2 seconds. How much? 2? Okay. That's more average. Like 2-3 seconds, it's like a good number. Actually, we did a study. This was with 500 typical users for mobile web, which was the thing they hated the most about mobile sites, and it was the slowness. So the amount of time people wait, it's usually between 2 and 3 seconds. Actually, if you wait 3 seconds, you lose 40% of your users. So you really want to be very fast. This quote I really like. This is Jeff Bezos, Amazon's CEO and founder. And he was talking at this conference, and he told people, as I'm telling you right now, that if you want a real problem, your target for latency has to be 1 second. It doesn't matter what you do. Every time the user clicks or inputs data on the mobile phone, the next action, it has to be ready 1 second after that. So that means that you have to go to your servers, construct the HTML, all of the information, send it back to the phone. The phone has to collect pictures, data, JavaScript, etc., execute everything, and present it to the user so that it's ready to click again 1 second after the click. It's not an easy task. If you consider that most people on mobile use 3G networks or 4G, LTE, etc. There's a lot of technologies, but 3G is the most common right now. And usually, what happens between your phone and the telecommunications in the area where you are, it takes like 600 milliseconds to simply do the handshake and say, hey, I'm somebody's phone and I need this information. And then that leaves you 400 milliseconds to do the actual work, which is very little time. So probably 1 second is not practical. Maybe you can aim for 2 seconds. And this is a nice model to create apps. If you are creating an app, or if you have a job where you have to construct new apps, you have to think about mobile. Actually, at Google, we are not mobile first. We are now mobile only. We are creating apps that work on mobile. We don't care about the desktop anymore. The idea is that if it works on mobile, it's probably going to work okay on the desktop. The browser there, it's more powerful. It can make sense of everything we do for mobile. So we are connecting only mobile things. And this model, it's very simple to understand, but it gives you a mindset to create the app, and it will give you the best practices to create an app that works not only on mobile web. You can also use this technology and this model for native apps. So the idea is to have the response under 100 milliseconds. If you think about that, it has to be really fast. So what we are doing, for instance, how many of you use Android? Most of you. It happens almost the same in other platforms, but on Android, the latest version, we have animations and we have a lot of movement on the apps, but this movement has meaning. When you click on a button and there's this ripple effect, that's actually the response that we are adding to the app. It's automatic if you're using the model, and the idea is to have the user giving them feedback. If the user clicks and nothing happens, probably it's going to wait 1 or 2 seconds, and it's going to say, maybe I didn't click or it was not registered, and it's going to click again and again and again. And eventually it's going to say, oh, this is not working. So the feedback, the animation has this idea to give you a response really fast. You have to be able to execute new frames every 16 milliseconds. That's usually a good rhythm for creating animations on the screen. And the idea is to complete chunks of work very fast, very small chunks of work. So if you had to do a complex task, divide that on very smaller tasks, execute each one of those. That gives the user some information. So bring part of the content while you are processing the other parts, and then bring the rest. This is from Apple. There's a site. I will give you the link in a moment. You can use this. It's very practical to test your website. Probably it's a good exercise to do in a little while. But this is apple.com being tested. And as you can see, this was simulating a really common practice in a smartphone using 3G. And this is the number of round trips you have to do. Actually, the phone has to ask the server for information once and again. And it has to do that 42 times. And it gets a lot of content. Most of that, it's on images, 68%. So you can do this to test if your website is already mobile friendly, how much work it represents for the for the phone, because every round trip, it's also consuming battery and content, etc. So you can always improve on this. Faster usually means higher conversions. This is almost like the key point. If you are selling this to somebody at your organization, or you have to convince your partners that it's a good idea to invest on the speed and making your site faster, this one is the graphic you want. There's actually, between 2.4 seconds, you see a drop on the conversions. We believe it's because those were 404s. So those were pages that returned an error. That's why they were so fast. And if you see an error page, you usually don't buy or convert. But if you have the right content very fast, it's going to be a great key. So how do we do this now? Why is web usually not considered the first option when you are thinking about mobile? And what are we doing about it? So I'm going to talk about these two technologies. I asked you at the beginning if you knew about them, and a few of you know. So I'm going to go over the two of them. But I will try to, this is the situation. So AMP and PWA aim to bring the mobile web to the same level as native apps. So that's the idea behind these two technologies. And you don't have to go very far. If you consider what happens on mobile, when you go to a website, somebody sends you a link, you're chatting on WhatsApp with a friend, hey, check out these nice shoes that I want to buy. And they send you the link, you click the link, you go to a website, and it immediately pops out advertisement, and it has a lot of content, Twitter feeds, and a lot of information that you really don't care about. So the mobile web on a very small screen, it's terrible. It's really bad. So the idea behind these new technologies is to clean up a little bit the mess we already did about the web and make it really fast. So the two technologies aim to solve the different parts of the model I mentioned. AMP, it's all about speed. It's making mobile web fast again. And PWA tries to make it like a real app, that it behaves exactly as your native apps. So the first AMP, which means accelerated mobile pages, it's basically a subset of HTML5, a subset of JavaScript. It contains all of the things you need, but the idea is to make pages that are really fast, very clean. So the first thing you will notice is that usually when you see the source code for a HTML page, you see things like this. It's crazy big, it has a lot of content, it has JavaScript, it has CSS, etc. When you create an accelerated mobile page, it usually has just one line, which involves everything you need. It has the basic JavaScript so that the animations that you see there can happen. But the best part about AMP is that it gives the phone the exact content or the exact dimensions of the content. So this is what happens when you start getting a web page, usually a regular web page on mobile or in any browser. It does a process that it's called reflow. Basically, that means that it gets content. Usually the first content is the text. Say you are seeing one of these news articles, so you receive the text, you start reading the text, and then it disappears, and it's replaced by a picture, and then the text is written again around the picture. And then you continue reading, and then it disappears again, and now you see a banner, then the picture, and then starts writing the text again. That reflow happens all the time. And on mobile, it's usually visible because it's very slow. You get the content a piece at a time, and it's crazy. It's going to happen the same with AMP. The good thing about that is that the browser never reflows. It already knows I'm going to receive, for instance, a picture. The picture goes here. It's this big. It has these dimensions. The text goes around, and on top there's an advertisement. That's it. So when the picture arrives, at the beginning the text is written. When the picture arrives, the space for the picture was already there. So it doesn't have to paint again the text. You can continue reading, and the picture is going to eventually appear there. And eventually, it's going to appear also the advertisement, which usually takes longer. So this is what happens. That's the basic idea. You can put content, rich content like video or music or pictures, etc. We are using it. Originally, it was going to be used only for news or static content like blog posts, things like that. Right now, we are using it for pretty much everything. And this is the other nice thing. When you are using AMP, we are putting a lot of resources across the world. So we have this AMP cache. These servers are all over the world. They are called edge servers, and they create a cache content. So whenever you create an AMP web page, it's going to be, if it's accessed from somebody in Africa or Southeast Asia or China, it's going to be copied the first time to one of these cache servers, and then everybody else in that area is going to receive the content from the cache. It's super fast, it's free, you don't have to configure it manually, it's going to happen. If you have an AMP content, it's going to be replicated. If you don't have that, every time somebody accesses your content, they have to go to your server. If it's in the United States, it's going to be there, or if it's here in Trinidad, they are going to have to come here for the content. And the user experience, it's going to be obviously very different depending on where you get the content. Right now, if you are using AMP, this is the speed, this is the medium load time for AMP content. So if you go to Google and search for, I don't know, Trump or Hillary Clinton and you want to read the news, typically this is what you are going to see. We used to have this news carousel. Right now, all the content we present in that carousel is AMP content. So these are pages. All of the pages you see here are AMP. They can contain videos or pictures, etc. So it's super fast. When you click on one of those pictures, you will immediately see the AMP page, and it's already in your phone. If it's in the carousel, it's going to be already loaded in your phone. The experience is really good. So for this type of content, in particular for Google, this is one of the applications for AMP. The experience, it's amazing, because then you can start reading immediately about the news you wanted to see. It's 4 times faster than the regular or the equivalent web page, and it contains 10 times less data. So that's medium. Obviously, it varies from content to content, but that's an amazing experience. Right now, it's moving beyond news, but the original idea was for news or fixed content. If you have a web with a blog, probably you want to use AMP for your blog. Actually, if you are using, for instance, WordPress now has a setting that you can say, I want AMP content. So it will create your regular content and also a copy, which is the AMP version of that content. It's super simple. There's no magic. If you already know how to create a web page, you already know how to create an AMP page. It's super easy. It's just a subset of the content. And now I'm going to move to PWA. These are progressive web apps, and the most important part in this is progressive. So basically what we want to create here is the second, third, and fourth of the 4 things I put there. The first one is engagement. You want users to go back to your site, and then they start interacting with your site and connecting with the content, etc. So progressive, as I mentioned, is the key part here. this is the things we want to solve with PWA. The first one is local caching. When you are using a native app, the native app has access to the memory or local disk in the device. It has access to offline, so it can download the graphics and the content, and you can continue playing even when you are not connected to the internet. You can add it to your home screen, so you have a very nice logo that you can click and the app comes alive. And finally, it has push notifications. So it can give you a message that, hey, somebody texts you and this is the content. So these 4 things are the things we couldn't do with mobile web. So PWA, it's an answer for all of this. And the way this works is through this very small JavaScript piece of content that it's called service worker. So if you are creating apps, do you have mobile apps? Okay, some of you have. If you have a mobile app, this is the thing you want to research right away. It's very simple. It's open source. Actually, both of these technologies are open source. You will see this as a trend in everything we are going to talk during the day. At Google, we believe that open is the best way to go for this type of technologies. So service worker is something that it's being worked between everybody in the industry. Firefox, Edge, Microsoft, etc. The only one that is not on board completely right now is Apple with Safari Mobile, but it's getting there. We hope they will join the party very soon. This technology makes sense. Probably doesn't make as much sense for Android and iOS because we make money out of the apps, the actual native apps. So it's not a perfect money maker solution for Google or for Apple, but it makes perfect sense for users. So if you have a small team and you have to create a mobile web app, an Android app, and an iOS app, it's going to be a nightmare. It's very hard for one developer or one small team to create amazing apps for all of these platforms. So if you have small resources and a small team, you have to choose one. And chances are that this is the best opportunity and the best option for you to create a mobile app using progressive web apps. So the idea with the service worker, which is this JavaScript client side, it's a thing that you download to the mobile phone. The thing is that it's very fast. It's a very small piece of code, and it creates an amazing experience. This is the coverage right now. So as you can see, most of the mobile browsers already support PWA. Not all of them. Safari, it's in between, and they have been working at it for some time now. They are usually not early adopters for technology, but they will get there. This is one of the somebody from Apple saying, yeah, people think they want PWA, so probably we will add it to Safari. This is a very large Chinese company. I'm going to give you a couple of examples. They moved their site, their mobile website, to PWA, and they saw a 74% increase in engagement. So users that arrived to the mobile site stay there a longer time, browsing, commenting, selecting stuff, adding it to the shopping cart, etc. So that's a big number. But even the iOS, as I mentioned, Safari does not support PWA, and regardless of that, they get 82% increase in iOS using Safari, just because the best practices behind PWA force them to create a better user experience in iOS. So it's also a good idea. And the small number you see here, across all browsers, it was 104% increase. So it's very cool. Oh, by the way, do you know that one? That company? Flipkart? It's probably not very well known here, but it's kind of like the Amazon for India. It's a very large company. And they have a very interesting story. It's a huge company. It's kind of like Amazon, really big. In 2014, they created their Android and iOS apps, really good apps. Actually, if you visit on the web Flipkart and you have a modern browser or a modern gadget, it's going to ask you to install the native app because it's really good. So the Android native app is better than their web version, but only if you have a high-end phone. If you have a feature phone or a not very great phone, the mobile web is much better. It's really fast. It doesn't use as much content, so it's a good idea. But these guys created the apps in 2014. It was a not great move. They started losing conversions and engagement by Indian people, and they didn't understood why until they started researching, and people was connecting on very small phones, on very shaky network, 3G, 2G connections. So they had to move back to web, and in 2016, they are one of the early adopters of progressive web apps, and now they have a very amazing mobile experience. I invite you to go to flipkart.com on your mobile browser. It's really good. You can go and do the thing you are seeing here in the animation, go on to airplane mode, so you are not connected to the internet, and you can continue browsing the store, see reviews, add stuff to your cart, etc. And when you go back online, it will synchronize with the server, add everything to your shopping cart. It's super cool. This is another example. Air Berlin is the second largest airline in Germany. And they understand that most people don't travel every week or every month. So if you are doing just 1 or 2 trips every year, you don't want to have to install an app in your phone. You will never remember that you have it there. If you just want to use it once a year, it doesn't make sense. So they created a mobile web, which is really cool. It has a couple of interesting features. The first one is that it works offline. So if you travel to another country, usually roaming services are very expensive. You don't want to have to go into roaming just to get your flight information or boarding pass, etc. So it works offline. The initial loading time is less than 1 second. The page is so fast. It's very simple. It doesn't show you everything you have to see. Let me just, for comparison reasons, last night I was testing Copa Airlines, which is the one we used to get here. And this is the, actually you can go to that site. It's a web page test. And you can test all of the pages you are using, your own page. It would be a good exercise. And you can see the numbers here, fully loaded. This is the best interesting part. It takes 8.4 seconds to be fully loaded. This was, you can change the testing experiment if you want to use 3G or full network or 4G, etc. It has to create 158 requests, and let me go down just to show you this is the breakdown. That's the loading page. Let me make this bigger. Mm-hmm. In terms of content, the Copa website, this is what you are loading. 64% of the content are images, which is not great. If you want to create a mobile experience, images are great. Everybody loves to see a very amazing picture of your hometown or company or product, but it doesn't make sense in mobile. So this is not a great idea. If you want to create a really fast experience, what the guys from Air Berlin did, it's much better. So this loads in under 1 second. It doesn't have a fancy image. It doesn't have much content, but it's very practical. And you get the boarding pass that you wanted offline just to go on the counter and get into the plane. Excuse me? Yes, it's the first time. Actually, this one, because it's very simple. It's just your information. It has a couple of really neat tricks. I will show you a couple of examples. For instance, it has also notifications. It's very annoying that when you buy the ticket and then you want to do the check-in. And you can do check-in 48 hours, 24 hours before the flight. You usually have to put that in your calendar. This web app, sends you a notification. Your flight is ready. Do you want to check in? And you say, click just on the notification, and it makes the check-in. It doesn't ask you for information or input text, etc. It's really cool. I wish all of the airlines, because I have to travel a lot, all of the airlines in Latin America were like that. There's another couple of interesting technologies. Some of these are to eliminate some of the friction. Have you ever had this experience? This happens to me all the time. When I have to enter my email and God forbid somebody asks for my password at a website because passwords have lowercase, uppercase, special characters, numbers. It's crazy. You have to start switching your keyboard and the asterisk starts coming up. It's crazy. But this happens all the time. This is the typical checkout process of any website, most of them at least, for the first time. The first time you register for Amazon, Mercado Libre, etc., you have to enter that information. Your name, your address, credit card information, shipping address, etc. The CCV, the expiration dates, etc. So this is the typical checkout process, and this is the number of people that drops. 97% of the people never completes the checkout process. They do the browsing, they spend a couple of hours in your site in a couple of weeks researching the products, they put the products on the cart. Eventually they say, yeah, this is the best offer, I went to the store, I went to other places, this is the one I want to buy it from you. They start the checkout, and in some part of this process, they drop, and eventually only 3% of the people completes the buy. So asking users to sign in today with email and password, that's crazy. Actually, we conducted a study for a lot of mobile apps, Android apps, native apps, and the apps that started with click that register or input your login and credentials, many of those are never used, not even once. People downloads the app, clicks on the app, and if the app asks for email and password, or it gives you the offer to register, most people say, oh no, I will never do it. Bye. And they skip the app completely. So that's not a good idea. There's a lot of options. You will see one today with the Firebase, but we have a credential manager API. It's very simple to use. You can use it to do Facebook login or Twitter login or GitHub login. I mean, you have a bunch of options so that people can select, yeah, I want to log in with Facebook. Facebook, it's probably already installed on the phone, so it's just a couple of clicks. They will get sent to Facebook. In Facebook, they have to accept. They get back to the app, and then they're logged in. It's super easy. This is another open technology. We have been working with many other groups, and now W3C, which is the organism that regulates internet and actually the web standards, they accepted this new API. It's called Web Payments API. It's not super popular yet, but it will get there. So if you want to do the checkout process simple, straightforward, secure, this is the way to go. The idea is that the user is going to be able to record the credit card information on the phone. It's going to be secure in their own phone. It never goes to the external site. And you only use the Web Payments API, and it will do the handshake securely. It will get the information to the store so that you can pay for the things without actually inputting the information. The last part, the retention, this is usually done through notifications. It's a very good idea. If you are using notifications correctly, users will get back because the notification makes sense. It comes in the right moment. For instance, when you receive an email, you see the notification, and then you go and read the email and answer, and your boss is happy or your spouse is happy because you answer promptly, and etc. So that type of notifications is really important. I was telling you about the Air Berlin. In general, this happens with all of the progressive web apps. When you use a progressive web app at least twice in 1 week, the phone is going to realize, oh, this guy likes this web page. And it's going to offer you, do you want to add this page to your home screen? And if you click here, you'll get the nice icon on the home screen. And the next time you go directly through this icon, you will get this. Can you see the difference between the one on the left and this one? It's just the web page. It doesn't have the browser. You cannot go to another page and switch. It's logged into this very nice web experience without the browser. So you cannot go to other web pages, etc. And all that happens is that it installs here part of the content, the layout of the screen, the logos, and the service workers. So there's something installed on the user phone, but it's very small. In terms of footprint, it doesn't compare to a full native app. And in general, if the app is well done, like this one, which is very simple, the experience, the user cannot tell. Usually you can tell. When you download a native app, and it's run a native app web browser, and it has a web view, for instance, in Android, you can tell, oh, this is a web page. This is not a native app. Here, if it's done correctly, you won't notice the difference between a native or a web experience. It's going to be very cool. The last thing I mentioned is the notifications. This is the one you get for Air Berlin. Your check-in is, do you want to check in? And if you say, yes, I want to check in on the notification, it will give you this web page. And when you are offline, you can click on that page, and it will show you your code to enter the plane. So that's one of the apps. I don't know how much time do you spend. How much time do you spend on Facebook every day? Do you know? Do you want me to tell you? Well, the average is like 45 minutes a day on Facebook, like actually reading stuff, commenting, putting +1s, etc. So there's a trend now. For instance, many of my friends deleted the Facebook app from their phones because it was like, no, every time I go to the phone, I go to Facebook. It's like automatic. I don't want to do it, but I do it anyway. So they started deleting the app. So that way, they open the phone and they go do some actual work instead of going to Facebook. The problem, and what they don't know, is that Facebook is very smart, and they did an amazing progressive web app a couple of years ago. They are also one of the early adopters of the web technology. So if you don't have the native app, don't worry. You can go to the browser, go to mobile Facebook. You will get to this very cool page. If you visit mobile Facebook a couple of times, it will offer you, do you want to install the mobile web page on your home? And then you will get the nice icon, the nice Facebook icon, and it will start giving you notifications, the same things you get from the mobile experience, but without the big app. So if you don't want the big Facebook app installed in your phone, you can go to the mobile web version. It's almost as good as the native. Couple of examples. Let me just conclude with this part. The idea right now is that mobile web was here. It was super fast, but it was not really capable of doing interesting stuff. With PWA, we get the mobile web in par with the possibilities of the native apps. In general, it's a trade-off. Of course, mobile apps will always get the benefit of the, for instance, Apple, they build the gadgets so that the apps take full control of the sensors, etc. So it's not going to be the same. You don't have the same capabilities. But if your web page or your mobile site is not super complex, or like 90% of the sites out there, it would be an amazing experience to create a progressive web app. So let me just finish with one very cool example, because this is the question probably you have right now. Okay, the two technologies are cool. Which one I want to use? Can I combine them in the same mobile experience? And the answer is yes. I will show you one example. This is the Washington Post. They are also one of the early adopters. As I mentioned before, AMP was created as a mobile open source platform. So it was a collaboration between many entities, Google among these ones. But the Washington Post was one of the first organizations involved in the AMP definition, and they have been there since day one. So right now, when you go to Google, for instance, and search for stuff, news, articles, whatever, usually you will get somewhere else, in the news carousel, you will get a notification like this one. This is from the Washington Post. When you click on that, what you get is the AMP page for that note. It comes from the Washington Post, and what they did, which is very smart, is that on the hamburger menu that you see on the page, they put their progressive web app. So when you click on the menu, what you get is the service worker for the Washington Post progressive web app installed on the phone in that moment, so that this menu is the access to the progressive web app, to the rest of the Washington Post. So when you click on one of these sections, actually you are browsing the progressive web app from the Washington Post. And from there on, you're converted. You're probably going to start browsing, and you're going to enjoy the experience. If you visit two different notes from the Washington Post in that week, eventually you will get the notification that, hey, we noticed that you like the Washington Post. Do you want to install this on your desktop? And then from there you are converted, and you will get the Washington Post experience on your phone. I don't think I put it here, but oh yeah, here it is. This is the Washington Post office, and what you see on these screens is the loading time from the current loading time of the pages people are watching on mobile browsers on the world. So they are striving to create this awareness. Guys, we have to create content, and we have to create great journalism. But if nobody is reading it, it doesn't matter. If people comes to the site and it's loading, it takes too long and the people leaves, it doesn't matter if it was a nice piece of journaling. So they are putting as much attention on the technology as on the writing they do. And that's why they have this on these are the guys that write the notes and put the content and the videos and the pictures. So they put the numbers there so that they know this page is not loading fast enough because the picture was too big. So they start changing content and making making it more attractive. 80 milliseconds, it's pretty good for a web page. That's under 1 second that we were discussing. It's very fast. And all of these technologies, AMP and PWA, only work on HTTPS. DS is for the security part. 10? Yeah, they said 10. Okay. Okay, so HTTPS, this is the last part of this first presentation. I don't know how much time have you been working on web, but on my time, we usually had to decide whether we wanted to use HTTP or HTTPS because there was a penalty, a speed penalty, and it was a convenience penalty for using security. It was slower, you had to buy the certificates. There were a couple of issues, and it was not as fast. So if you wanted a really fast experience, you had to do it on HTTP without the security part. Right now, actually, it's a very bad idea to not have security, even on very simple web pages, because somebody can intercept that information, modify it on the middle, and show people things that they don't want to see. It's very easy to do that. So HTTP/2, it's the version 2 of the HTTP protocol, which is the one we use to interact with mobile servers, with web servers, I'm sorry. And this is the performance you get. This is the exact same image. It's being, the animation is being recorded using this protocol, HTTP2 on this side and HTTP regular on the other side. And as you can see, the performance, it's really good. So right now, the issue about performance is no longer a concern. The cost, you can get very inexpensive certificates. Usually certificates have a period of 1, 2, 5 years. So you have to be mindful that you have to buy again your certificate every certain number of time. You can even get free certificates at some sites, and it depends on what you do. For instance, non-for-profit organizations can get always free certificates, things like that. So you don't have to worry about the cost of buying a certificate. The performance, if you use HTTP2, which is the one you should be using anyway, it's no longer a concern, security or no security, it's really fast. Advertising, most of the ad networks out there support now HTTPS. It was a big concern. For instance, if you had a blog or a newspaper, many of these couldn't use HTTPS because most of the ad networks, which is the best way to monetize content, didn't support. But right now, most of them do, so it's super easy. In general, so you can use HTTPS. If you want to check out some of the logos in this page, these are web apps that are progressive in some form or another. Not all of them support all of the progressive options. We have service worker for all of the different activities. But if you go to any of these, you will see a very decent user experience on mobile web. And it will give you an idea of what you can create. Right now, the list is crazy big. It's growing every day. People are switching to AMP and eventually switching to progressive. So give it a go. And these two are the main web pages for these two projects. Both of them are open source, are free. So you can get the content or the code in GitHub. And that's it. Thank you. Now, I think, is this a time to do a break or should? Yes. Oh, yes, sorry. Yes.
familiar with
Hybrid?
hybrid mobile apps. Yeah. Do you think this would PWAs would replace it?
I,
It's like this.
I think so. I think so. When you do a hybrid app, it's usually because you have a bunch of content on web, which is valuable. Like, I don't know, for instance, news about sports, they have the videos and commentaries on the web. So usually you have a native app that at some point gets to a web view and includes all of the web content. That's typical. And I think if you create a great mobile web, you don't need the hybrid part. It's just going to make it heavier. So eventually I think most people will decide on this. As I mentioned, it's not equivalent, but for most of the sites that I know that are hybrid, I think it makes more sense to have a great mobile experience than to have the hybrid app. If you cannot create a great, amazing mobile app completely native, probably it's best to do a nice mobile web app. Another question about this?
Does it interface with the native apps like the Google Calendar? Like if you have a
Yes. Yeah, probably that's what we were talking about. Yes and no. When you have a mobile app, there's a lot of APIs that you can connect your app to. Some of them have web versions, in particular calendars, etc. It's very easy to integrate to mobile web. So yeah, it depends on the specifics, what you want to connect to your app.
So like the flights,
Mhm.
the journey mobile web app.
Yes.
If you have it reads your email for the tickets and times like that, could it then open up the mobile web app on the phone, moving from the native app to this now mobile web app?
Yeah, of course. Yes, you can do that, and you can also connect the mobile web to other apps. For instance, you can, if you have an appointment and you say yes to I just bought movie tickets, you can add those to the calendar. Yeah, you can connect. Actually, those are protocols from Android or iOS. You just have to register the service. This is the app that is going to handle this type of content. Yes. Okay, let me. How long is it the break? 15 minutes? Okay, so if you want, let's go for the break, have something to drink, 15 minutes, and then I will continue now with the Firebase and the new stuff on Android Nougat, and then we'll go to the code lab on Firebase. Is that okay? Okay.
We'll be doing push notifications.
Excuse me?
Would we be doing push notifications today, Writer?
Push notifications? Yes, with the progressive web app. Yes, there's a service worker for. Actually, that's the one that it's being used the most. For instance, Facebook uses only the push notifications. Flipkart, they want to buy stuff on India, they use push notifications and offline. But those are different service workers. I'm sorry, I cannot hear you. Good. Yes. Yeah. Okay. Ok. Entonces, 15 minutos. ¿Cuánto? ¿Y luego cuánto es? Son 2 horas y luego te toca a ti 2 horas de Code Lab.
Tengo 4 horas de Code Lab.
Shit. Ok.
El Code Lab en realidad.
Ah, bueno, yo
el Code Lab
tengo
dura-
todo el contenido de.
El Code Lab dura 1 hora. O sea,
Ok.
puedo. Como creo que. No sé, no sé si puedan instalar ITeS. Igual y si quieres. Porque La parte que vas a mostrar de Firebase, que tan larga es.
Es súper larga, pero me la...
So excuse me.
Yes.
You're handling the other part of the presentation?
I will continue, and then probably like half an hour more, I will
So I
continue.
just need to switch you over when you
Okay.
when it's your turn.
I will, yeah, I will let you know. Do you need to switch this off, or can I leave it?
Yeah, save the battery a bit.
Yes.
Just do a call back before we start. You got something to? You got something?
Yes. That's good. Thank you.
All right, guys, let's just settle down.
Okay. Nice. Now we have food on our bellies, and we're happy. I'm going to change the order a little bit so that we cover some of the things we have on the Google Cloud platform, and then I will pass the torch to Toño to talk about Firebase and do a code lab. That would be the first practical section. Then after Toño, probably it will be lunchtime, and after lunch, we will talk about machine learning and another practical session with Vision API. So let me tell you about Google Cloud Platform. Actually, I'm going to start with this small video. So the idea behind the video, it was created for our next event, which is the idea we are trying to bring with this Google Cloud platform. Basically, one of the things you want to get away from when you are building a new company, a new business, a new idea, is to go away from the small details, the DevOps of the world. I love DevOps. I grew up in that technology, Linux, and everybody wants to get into that and create their own infrastructure. However, when you are creating content, when you are creating something useful, that's usually a lot of work and it doesn't add any value. So what we are planning on doing is moving from these IT silos that was the way to create apps in general business in 2010. We are moving to this distributed computing. And basically that's what Google Cloud is all about. It's a lot of small pieces that for some business make sense, so you use whatever you need, are the building blocks that you use to create a complete business. Since you are building a prototype until you scale to thousands or millions of users across the globe. That's the idea. And what we are planning on, the way we are planning on doing this is to offer you a cohesive experience. So we have a different version. This second wave of data centers we have, they offer user managed, user configure, and user maintain infrastructure. So we have infrastructure as a service, a lot of small things there. platform as a service if you just want to create content on one virtual machine. And we also have the last layer, which is software as a service. And in this second wave, we are focusing on different stuff. The first and probably the most important for people to start moving from their on-site servers to the cloud, to the public cloud, is a part of security. Let me give you an idea. We started doing these blue hexagons, which are the different components of the Google Cloud Platform. Each of the logos you see here represents one of these large components and things you can use. However, we don't want to be a set of blue hexagons offering different stuff. The idea behind this, and that's what the video was trying to explain, is that we have these three very large sections. If you consider your business as a whole, the first part, it's all about data and analytics. You have to start collecting data from your users' interaction, what's happening, where they are spending the most time, what parts of your site or your app are never used and why. And once you understand that data, you can create application development to correct that information, to integrate better with your users. And basically, and finally, I'm sorry, you want the infrastructure and operations to support this as a whole. So these are some of the technologies. The blue hexagons you see there are here. You see two-factor authentication, for instance, which is very relevant. If one service offers you two-factor authentication, it usually means that it's going to be very hard for attackers to forge that information or to get in the middle, etc. And it's very simple to integrate. If you use these technologies, you can add two-factor authentication to any app, and we will take care of everything. We have all of this in the security platform. Compute. You want to have less downtime. That's one of the main goals of cloud infrastructure. The promise is that you will have like infinite resources, and they will be always available. In practice, it's very hard to give that, but we are getting there. The cost is going down, and the uptime is going up. Not only in Google, basically all of the. Right now, it's probably a three-horse race. The leader in this field is Amazon with AWS. And then you have all of the Microsoft offering and Google. There's a lot of other smaller competitors in different areas of everything you will see here. However, as a complete solution, the full stack, it's very robust. We have a global network. Right now, probably it's one of the largest networks in the world. We have different sites in different areas, and they are connected to one another. And we also have this global network of edge servers that get you close to the user. This is the typical data center electricity use. Much of the electricity in one of these data centers is used for the data center itself to keep it at certain temperature, etc. And in Google's data centers, all of the electricity or most of the electricity goes directly to the servers, not to the infrastructure to support them. So we have a lot of innovation in these data centers. It makes it very, very easy for us to scale and to offer services that are cheap, that you can get to them very easily. Actually, we are generating 3.2 gigawatts of energy every year. These are the regions. When you go to cloud.google.com and create an account, actually you have to create one for the Code Lab, or if you already have one, we will use it. And we have these zones. This means we have different data centers in those parts of the world. In 2017, we are adding 6 different zones. We have a data center in Chile, and probably we will open in Brazil and other regions in the world. These are the typical savings when you are considering moving to the cloud. Usually, what you can expect, especially if you are using this for long periods, for instance, all of your infrastructure is running on Google Cloud Platform, you get the sustained discount, and you get up to 59% savings on that infrastructure. And it's all elastic. That means that you pay only for what you use in terms of computer cycles or disk, everything. Kubernetes is probably the latest technology. In Google, for the past 10 years, we have been working with containers. Everything in Google runs in a container. These containers are like virtual machines that you can easily install in your computer when you are developing your software, and you can deploy to different architectures in different data centers very easily. This makes your application faster to move from one infrastructure to other, so it makes sense. We have a lot of open source technologies that are available at the data centers. You can select different operating systems if you are working directly with the infrastructure, or if you don't want to use that, you can use the platform as a service and simply run your Java or Python or JavaScript code directly. So basically, this is the dream. We want developers to simply start writing code and never have to worry about where this is going to be deployed and executed and who's going to take care of those servers and maintenance and etc. That's completely transparent. You just focus on your code and you let the rest to us. We will become your DevOps. We will take care of your machines so that you can only develop and create amazing experiences. This is very typical for all of you developers and people that have created content. This is a crazy, crazy job. You not only have to take care of what the code is going to look like and what technology and IDE are you using to develop this code, you also have to take care of everything else, where it's going to run, who's taking care of the servers, etc. The idea behind all of this is that we want to offer you this in a packaged way. Our platform as a service experience, it's called App Engine. This was the first offering of Google Cloud Platform, like 6 years ago. So if you go to App Engine, right now we are serving 100 billion requests per day from App Engine, and those are this is the platform as a service offering. We also have a lot of data processing. We have reliability and many other things that you need. Big data. BigQuery is probably the best example we have of big data processing. It's like a data warehouse. When you use BigQuery, the idea is it's like a relational database without the relational part. So you basically take all of the data you have, put it together in a single huge table, put it in BigQuery, and you can start making really fast queries, thousands, millions of lines of data. It's not a problem. It's super scalable, and it gets the job done. So we have a very large offering for data management, from MySQL databases to NoSQL, or big data, etc. So you get to choose what you want to use. Data store is the Google's file server. So right now it's serving 15 trillion requests per month, and it's very easy to use. You can use it to store any kind of content, from documents to pictures to videos to any size. So, and basically, the thing that it's probably connecting everything together is the machine learning that we are putting on top of everything else. So right now we have a bunch of APIs. We are going to do a code lab with one of these, which is the Vision Cloud. Vision Cloud? Yeah. API. But all of these are making all of that data that you are collecting to come alive, to be able to tell you more information about what you have, what you can do with that, etc. These are some of the most obvious things you can do with some of these. For instance, with Cloud Vision, you can do face detection. Sometimes you have a service where people can upload images to your service. Imagine social networks or Snapchat or etc. But you want to avoid somebody adding information not safe for kids, for instance. So you can do that with Cloud Vision without having people to review and approve a posting or not. You can do that automatically. Detect if there's a person, and if the person is nude, then stop it and have somebody reviewing the content. Or things like that. You can do OCR or logo detections if you don't want to put that information. Cloud Speech, right now it recognizes over 80 languages, so you can either translate or understand somebody speaking to your app. Right now we are moving to this. Yesterday we had this very interesting discussion about bots, which is now all the rage. Everybody wants to create a bot so that people can interact with the bot, and you have somebody typing or talking to your app, and the bot is going to answer with whatever it is requested of the bot. It's great. It's a good idea, but it's not for everything. Right now what I'm seeing is a lot of apps that are putting a bot instead of creating a better app. Usually what you want is just a couple of clicks, and you have whatever it is you want. Like the Air Berlin example before, you want to get the check-in done very fast. So if Air Berlin, instead of giving me a one-click option, gives me a bot, it's probably not going to be great, because I'm going to have to talk or type to the bot and say, hey, can you please check me in? And it's going to take me a lot of to do what I can do with just one click. But in general, Cloud Speech is very useful. We have the Assistant, and we have Google Home, and we have a lot of technologies that uses natural languages to recognize what you are saying, and it creates a search or opens an app and plays music, whatever it is you ask of the Assistant. It's great for that type of content, but it's not for everything. So you have to be careful with that. This is the text API. It can recognize paragraphs, lines of text, particular words, and it knows about, for instance, consumer goods, or the title or names of organizations, things like that. And you can connect all of them, and you can connect them to your content. That's the interesting part. For instance, it's being used by many politicians when they are campaigning to analyze what's being said about the candidate. If it's positive, if it's negative, if it's hateful. You can recognize how people is talking about the news. You can start browsing Twitter content and decide whether you have to do something differently or continue what you're doing. These are some of the links. Actually, the one-stop shop right now that we are collecting everything is cloud.google.com. But these are some of the specific. You can go there. Many of these options have a 5-minute jump start, so you can start creating content. You will get the vision one here. And actually, before that, I have a fun presentation about what machine learning is and how you can use it. But this is only the different parts. In general, what you need to do is, when you are talking about machine learning in general, you have to select the data set that you are going to use to train the network and then create these models. All of the ones I mentioned, Vision API, speech, and text, all of these are already trained. So you can start using those immediately. You don't have to train them. These are some of the companies that are now Google Cloud Platform clients and the success they've had with some of the content here. For instance, Spotify, they have 75 million users. They have a lot of songs, but the interactions created by users, the playlists, etc., that creates a lot of knowledge, a lot of information that now allows Spotify to suggest you some information. Are you users of, for instance, Google Play Music? Have you tried the new version? If not, give it a go in your Android devices. The last incarnation of Google Play Music has a layer of machine learning, so it can offer you smart lists based on mood, or if you are working, or at the gym, etc. And it's very, very, very cool. The experience, it's being improved as more users get to say, no, that song I didn't like that song. It starts learning. So it creates very interesting lists on the go with music. And this is what we are planning on doing next. Many of the APIs we have right now are open source. Part of the machine learning technology we created, it's called TensorFlow. It's now part of the open source project. We still have a bunch of other technologies not ready for public consumption and not open. But in general, this is what we envision, to have most of these technologies open source so that they can improve faster by the community, by everybody using it. And then to offer a platform where you can go very easy from one platform to another. We want to avoid the vendor lock-in, which was very typical for tech companies in the late 80s, 90s, 2000s, because that was the way to retain the user. I'm going to give you a developer stack this big, and it's going to be super good, but it's going to be very hard to move to another company or another platform, etc. In general, that's not our view. What we want is for you as users to love the product, to really get value out of these technologies. So with this, I'm going to stop now so that Antonio has time to do the code lab, and then we'll get back to machine learning after the first code lab. Sí. Gracias.
Just clip this on the bottom.
Thank you.
Hi guys, I'm Antonio. I'm Antonio Guzman. I'm a software developer and I'm a member of the GDE program, Google Developer Expert. I'm a developer expert for Google Apps Script/Drive. And this time I will talk about Firebase. Sorry for my English, it's not my first language. And I will try to do my best with the language. Are you familiar with Firebase? Yeah, many of them. No, this Firebase. Firebase started a few years ago like a database, a real-time database with a simple schema for synchronization and features like social login. Was really simple to use, and a few years ago, maybe 2 years ago, Google bought Firebase, and then Google started to add more features to Firebase. Right now, Firebase is not only a tool to synchronize data or implement in an easy way social login. Right now, Firebase is a platform, for developers to create strategies, to get users, to get money in your apps. When I talk about apps, I talk about mobile and web apps. And sometimes you can integrate or communicate Firebase with some devices. Maybe later I will show a little demo. You can interact or control some devices like this Intel Edison. This board you can manipulate using Firebase. And we will talk about these new features. Originally, Firebase only had this feature, real-time database, authentication, and hosting. And right now has more than 15 features. And all these features are related to analytics. Google is really interested in offer us data about our apps. You can create or implement software solutions, but it's important get metrics about your apps. Then Google offers for free all analytics if you use Firebase. In this slide, you can, if you have apps in Firebase, you can access to the dashboard and get info about your different apps, iOS or Android, sometimes web apps, about the monthly users, how much money are you earning with the app, the number of errors, users reached, a lot of data. But for developers, we have these features. The real-time database. Right now, the database is a NoSQL database. You can store or save your information in JSON. If you can represent your information as a JSON, you can save it in Firebase. Firebase will help you to synchronize. You don't need to worry about the synchronization. Firebase will help us with you insert info, delete info, or update some information. Firebase automatically will push the modification to other clients. You can work offline. Many people lost the Wi-Fi or the signal sometimes is not great for our phones, but don't worry, Firebase can help us. Firebase can use the local storage, and when you come back online, you can push the data to the server, and Firebase will try to resolve some conflicts if there is conflict, and then push for all clients the new information or the new data. Authentication. Paco was talking about how many people doesn't like the apps where you need to create a user account and define a new password. You can use a simple and social authentication for your app. If you are using Firebase, you can implement the social login for Google, Facebook, Twitter, and GitHub. But if you want still create a custom authentication, you can define a schema for email and password, and it's really easy. Hosting. If you need publish a website, maybe for a project, or maybe you need publish your landing page for your project, you can use hosting. You can serve static assets like images. You can serve JavaScript files, CSS files, and HTML files. And you can use your custom domain. Firebase can offer you a generic domain, the number of your project.firebaseapp.com, but if you have the name of my awesomeproject.com, you can use. Storage. Maybe you are working in the new cool app for take photos for cats, and you need save pictures. You can use Firebase to storage pictures, video, audio, whenever you want. You can use the Firebase storage. It's based in Google Cloud Storage, and you can serve using the infrastructure of Google to show the data stored. Cloud messaging. It's really useful to maintain engaged the user. You can send notification to try to generate a call to action, to try to promote interaction with your app, and you can define target. It's not for all your users. You can select only a subset of your users and send notifications. Remote config. It's one of the most interesting features. I like this feature a lot. Many people hate update their apps. My mom is an example. When I visit my mom, she talk with me and show me. She showed me the smartphone, and she say, I have a lot of updates, but I'm not sure if I must update the apps. She's scared about the updates in her phone, but maybe you can avoid the pushing new updates for simple or common modification, you can use Firebase to define some variables in the server side. Your mobile or web app is using the server side app, the server side variable, and then you can modify the value without redeploy the app. And the next time when people access to your app or your website, you will get the new value. Maybe you need modify a promotional code. Maybe you can change the color or some interactions in the UI, and it's really easy. And if you are interested in mobile development, you can use this feature, ITeS Lab for Android. There are a lot of devices there are a lot of devices for Android. Many people has devices with a small screen, and other people have big devices. There are a huge number of devices. Then it's so difficult to have all devices to try your app. But Firebase can help us. You can program and develop your app, and then you can try your app in the most popular devices. How it works: you publish your Android app, and the ITeS Lab simulates how it works in the devices and show you the result, how it works for maybe a Samsung Galaxy, how it works in a Motorola Nexus, how it works in a Huawei, and you can be ready to publish a better app because it's was tested in more devices. Reporting about the performance of the app. And we are developers, but we need money. We have bills, we need pay. And we need users, we need create a business. And Firebase can help us. Firebase can help us to send SMS campaigns, emails, has a widget to share your app. We can use dynamic links. If your users are using iOS or Android or web, you can define different behavior for your app. If your users don't have the app, you can redirect to the App Store or Play Store to download the app and then return. And you can preserve the state using the URL. You can connect with your AdWords campaign. App indexing. Are you familiar with app indexing? If you do a Google search and there is an app related to your search, Google can offer you, hey, please, if you are looking for pictures of cats, maybe Google can offer you this app for cats. And you can use this feature to try to promote your app. And if many people is using your app, it's better the ranking in Google search. Notifications, again. And you can integrate. If you need show some advertising, you can connect with AdMob. If you have a campaign, you can use it. But it's time to write some code. This is a public code lab. you can access to this URL. And you can use what is the purpose of this code lab? Is build a chat. We will use different features of Firebase. We will use the hosting to publish our web app. We will use the real database synchronization. And we will use social authentication. And we will use storage to save images. The no, creo que ya está. Yeah. Many of you are familiar with Firebase. What kind of apps are you developing with Firebase? Messaging. Maybe one. Only Nicholas is using Firebase? Yeah? Maybe it's the only guy who will win a sticker. Yeah, I have stickers, of course. I have some stickers. Yeah. I have stickers and candies. Yeah, of course. Let me. No, I have a sticker. Please take one and continue passing. Yeah. Ready, guys? Yeah. The first step is clone the repository. This repository contains a skeleton for a web app and skeleton for a mobile app and Android app. It's the web and the Android version of the same app. We will use the web version. There is the complete code for the app in the directory web, and we will use web start to modify and explain what kind of things are we doing. I already have the code in my computer. I will use this IDE. Don't worry about it. If you have some issues, don't worry. We can check later. And there is this is a public collab. We can check after a session, and we need to create a Firebase project. To create a Firebase, we need go to Firebase console, go to firebase.google.com. There are some examples about the features. Some companies using Firebase. And get start for free. And we need to create a new project. I already have one. I will use this project. But if you want create of, you only need set a name. Create, yeah. Do you have your project? Yeah. To create a project, you need a Google account. And you need. If you want enable the social authentication for Firebase, you need go to authentication features, click on it. Maybe the Wi-Fi is not helping. And there is a tab for sign in. There are different options. You can use a custom email signing, Google, Facebook, Twitter, GitHub, or anonymous authentication. We will use, for this example, the Google authentication, but you can mix everything. You can implement all of them in the same project. It's downloading?
Yeah, taking a while to download the sample. So
Uh,
you can catch up on that.
Yeah. Maybe one of you are downloading the project. Don't worry, maybe you can download later, and you can follow the collab. In this case, we will enable this option. You only need to choose the social signing. Select enable and save. For other options, you need enable and set information like your app ID and your app secret. You need visit the Facebook developers page to get your app ID and your app secret. It's the same for Twitter. No, in this case, it's not mandatory set a secret, an API key for Google signing because we are using the account related with the project. Then it's automatically authorized.
For the developer console, would you see the information for this already created?
Excuse me?
The developer console, if you go there, would you see the app secret created for this project? In case you want to integrate it somewhere else. The app secret ID as well?
Yeah, you need go to the console for Google Cloud Console to see the key. Yeah. Keys for Twitter. En realidad solo necesitamos cualquier editor de texto. I don't. Maybe text.
No, that's it. That's empty. That's the application. Right now it's empty.
But you can edit your files using the text editor in Windows. You can. This is your web start and index. Open with. Where is the text? Maybe use Notepad. It's not the. Whoa, no, it's not friendly style.
Do you have another editor?
Online editor. Excuse me. Give me a minute, guys. Tracy? No, no está. After enable the Google sign-in, we must save. Save. And it's time to install the Firebase tools. The Firebase tools would be really useful. Are a set of Node.js apps to manage our projects, and you can copy this command to install your Firebase tools. It's a Node.js application. Maybe the machines doesn't have don't have Node. Yeah, your laptops have. After install your Firebase tools, if you already have your Firebase tools, it's really important check the version of the tools. If you have the the version 2 of the Firebase tools is not good. You need to use the version 3. But if you install right now, you will get the version 3. I have some problems with my permissions. Then need run as root. And you can use this command to log in from console to your project and authorize Firebase to Firebase tools in your computer to modify your project. And to set your project, you need to use Firebase use add. This command is really useful if you have many projects for the same console. Yeah, and then sudo Firebase minus add. The console is, Firebase tool is asking me which project do you want to add. I have 2 projects for this account, demo dev or it's only. I will use it's only a demo, then select it. Do you want an alias? Yes. The same name for my, it's. And we can continue. We can use the Firebase tools to simulate how it works in a server, and we can start a local server to run our app. Sudo right now my app is running on the 5000 port. Yeah, I have a web app to write some messages and select pictures, but right now it's not working. You must first sign in. We must implement some code. We must define some behavior or implement some behavior using JavaScript. You can use Firebase in almost all languages, because Firebase has a RESTful API, and Firebase has specific libraries for different languages, like Java, Node.js, and you can, if you are using .NET, you can use the RESTful library. There is a library for C++ and Java, and a library for Objective-C, and the team is working for a library for Swift. But right now, we need to implement the code in main.js. We have functions in this file. We need the functions to initialize our database. We need functions to load messages, save messages in the database, to show images, and synchronize the info. Then we need implement. The first step, we need init our database, and we must init Firebase. What are we doing here? We are creating some references for authentication for our database services and the storage service, and we are instantiating the Firebase authentication property. And we need a login. We need to implement a login for users. We need a logged user to can send a message. Then is the sign in function. We are working with Google Authentication. We are use the Firebase reference and the property to use the Google Auth provider, and we will ask for a pop-up to can log in. But if you are interested in use another social login instead of Google, you only need change Google for maybe Twitter and return to your Firebase console and go to the authentication option. Choose sign in and enable Twitter. Set the API key, the API secret. You can get your API key and your API secret in Twitter for developers. And in your code, you only need to change this line. If you want more authentications, more options to authenticate, you can use both, but you will implement a different function or and implement a specific button for Twitter. Yeah, in this point, we have the authentication for Google. It's just 2 lines. And to get the sign out, just implement. and add this line to set the properties for username and profile pic when the user is logged in. Oh, no está change it. Es aquí. And check in message. Yeah. After these changes, you must refresh your web browser and nothing is happening. Maybe something is going wrong. No, creo que ya sé qué es. ¿Qué pedo con esto, güey? The app is not showing me the signing button. I don't know why. Maybe. Yeah, I the signing is. I don't know why is. Let me close project. Let me open my old project. So it's not working. No mames. No lo está haciendo, güey. Ah, aquí. A ver. Let me check. Yeah. This is still working. Yeah. It's all right. Yeah. Yeah, it's working. Maybe was the cache. In this point, we have this web app with the signing with Google option. You can click on it, and you will get a pop-up asking for permission. I already authorized, and then redirect me to my app. It's using my name and my profile picture. I don't have picture. And you can send messages. But we need implement we need be able to retrieve messages from database. Right now, I can write, but I need retrieve the messages from database. If you have a JSON, you can upload your JSON file to your database. You can choose from your project. Import JSON. And we must select the initial message JSON, import, and right now we have 3 messages with for anonymous user and 3 different messages. Hello, how are you? I'm fine. You can create backups of your data. You can save your info in cloud storage or download your files. and we need implement this function, load messages. In this case, we are setting a reference for database, and we will use a reference for messages and a specific node of our database. And we will get the most recent 12 messages. And in Firebase, you can define some kind of listeners. If someone add messages of listeners for if someone change the info or delete the info, you can get the most recent 12 messages. You can set any number. For load messages. For load messages is igual. For this time, the most recent 12 messages. And then we can refresh our app, and we will get the 3 most recent messages from our database. If I modify some message, hello TNT, let me edit. No me deja editar, está así, no puedo editar uno de mis registros y me dice, necesitas estar autenticado. Estoy autenticado, si no, no podría ni verlo. Pero bueno. You can, in Firebase, you can define some rules to protect your info. It's so important control the access to your database. You can ask for login, or you can let access to your info for reading mode or write mode. Just writing a JSON file. In this case, the name is database rules JSON. You must authorize for authenticated users or public users. You can ask for already existing users in database. And if you are using your own set of rules, you must declare in Firebase JSON file the database entry and set the property rules and set the value for the name of the file where you define the rules. And we need deploy our app. We can use this command, Firebase deploy. When you have, if you have a web page or a Firebase project, if you want to deploy and test online, not only local, not only in your local host, you need run this command, Firebase deploy. Firebase will ask some questions, and the Firebase will respond with a URL where for your project. It's the name of your project .firebaseapp.com. And then is sudo Firebase deploy. Yeah. Deploy is complete, and then Firebase return a URL for hosting. You can access to my app. Try please. It's only a demo.firebaseapp.com. But to send messages, to save the messages in Firebase, we were talking about the JSON files, and the Firebase database. Firebase will save the information like JSON. Then you will need define a object using the typical structure: key, value, key, value, key, value. I have three properties for my messages. I store the name, I store the text, and I store the URL of the user. To save in Firebase, I only need use the push method and send the JavaScript object. Someone is trying my app, please enter to itsonlyademo.firebaseapp.com and write some messages. After save messages, we will save images. In this case, we will use a different reference. We will not use the message ref. We will use the storage ref, because storage ref is related to storage service, and we will use the method put, and then only save the images. We will build the new structure for our image: current user ID / the date and / the file name, and we will save this image in Google in Firebase storage with this structure. Anthony Hosang. Howdy, hello, and Firebase is updating the info in your browsers, and is updating automatically the info in the database. Please, someone send other message to and hi. Yeah. And for your images or different objects stored in Firebase storage, also you can define a set of rules to protect and control the access to your information. You can restrict who can publish or upload images, files. You can validate the meme type. You can validate the extension of file. You can set a limit for the file size and define some another rules. Who can read, who can write. And again, you need add this set of rules to your Firebase JSON. It's a kind of global configuration file. Define the property rule and set the value with the name of the file where you define the rules. And then deploy again. Please, I will publish. I'm not sure. I think it's only available in the US. You can upload images, and Firebase will save your image remember, Firebase is using the user ID and material previous images. Maybe is machine learning. Maybe it's that. And you can get a preview of your image. You can delete the image or download. Como que no está habilitado. For your data, you can remember you can write your rules in your local environment and then upload, or you can modify in this tab, selecting database and then rules, or you can simulate. You can use the simulator to try your rules. create backups, and the hosting has an interesting feature. You can do a rollback. Sometimes the apps, maybe you can deploy a wrong version. You can do a rollback of a previous version, and it's so fast publishing the previous version. You must select the previous version and just click on rollback, and Firebase will start to serving this version instead of the previous version. And it's all. I think it's time for lunch. We finished this collab. We have many issues. Sorry. But you can try this collab in your personal computer. You will only need your Google account. Go to Firebase console, create a project, install your Firebase tools. Before you need install Node.js and clone the project to modify the code. And if you are interested in the Android version, the repository, this repository has the version for the Android app, the same Android app. And you can test from different devices. And remember, Firebase is a useful platform to develop different kind of apps, mobile and web apps, and has a lot of features for you. You can create campaigns to get users or re-engage your users. You can set advertising in your apps, or you can use this feature for developers. You can test your app in many devices, get reporting about crashings, storage your assets, or hosting your HTML web app. And thank you. It's lunchtime. Who is Dante? Take a sticker. Choose one. Who is Mikel? I hope. Please share the stickers with Mikel. And Anthony, who is Anthony Hosang? Yep, share the stickers. And yeah, Jonathan, who is Jonathan? Stickers for you. And Nicolas, yeah. I like the JetBrains IDEs. Are you familiar with JetBrains company? Yeah, I have codes for 100 discount, 100% discount. Maybe in the next demo I will organize kind of contest. No. Yeah. Yeah, and yeah, to learn more about Firebase, please use these links. There are many code labs for iOS, for Android, for web apps. For if you want to mix with Polymer, you can use Firebase and Polymer. There are different code labs. And when someone access to your app, you get the info about some users. I will delete the account just for. ¿Qué? Sí. No. Eran- Ya. Pues ya, ¿no, Paco? Creo que. Creo que de aquel lado un par de chicos que ya tenían, lo hicieron en sus propias. Ajá. Sí. It's time for. Yep. It's time for break. Yeah.
Everybody's finished their labs? Yes?
Sorry.
Yes? Yeah. Alright, so lunch is available. It's in the canteen, I believe. Cafeteria. So you know where it says I assume. So take it. Please return here in 45 minutes, please. Thank you. 45 minutes. So that takes it till 1 o'clock. So 1 p.m. please return to the lab.
¿A qué hora tenemos que acabar, Toño? Bueno, voy rápido, como 20 minutos, yo creo, 20 minutos, media hora máximo. Y tú tienes otras 2 horas, ¿no? No.
One of the things I wanted to point out is there is an opportunity for you to engage with Google, I think, more interactively. So, if it is you want to indicate that you want to see certain things, you want to talk about certain things, feel free to put your hand up and say, look, I want to see. Don't just consume. Don't just take it all in. Engage. I'd like to see this. Can you show me this? Might not see it today, but certainly you can have it on the plate for next time. Right? So feel free to do that and don't just sit and just take it all in, and when you leave you say, I didn't really ask that question. So feel free to ask the questions, right? Is that clear? Yeah. Good, because the guys want to hear from you. Right? So I think it's good for you all to. So if you want to say something now, feel free. Before we actually start, anybody wants to start by saying anything? Put you on the spot? Yes. Maybe I just real slow so you can.
Google will expand Trinidad, like how Microsoft expand, how Microsoft store.
Like offices in the region? No, I don't think so. No, unfortunately, we have now 7 offices in Latin America, 2 in Brazil, and Argentina, Chile, Colombia, Peru, and Mexico, and Miami, if you count Miami as Latin America, which is almost. But since the operation is mostly commercial, we don't have that much of a need to expand globally, like with offices. We have people that covers the region, but no, I don't think so. And but what I can tell you is that we are always hiring. So if you want to get into Google, by all means, find a job that you like. We hire globally. So if you find a position that it's interesting in San Francisco or Switzerland or Argentina, you can apply for that one. So we cover pretty much all of Latin America, including the Caribbean, but no, I don't think with an office. It takes a long time.
Any questions? Anything else? Thank you for starting the board rolling. Any other questions?
How much does it cost? I will give you the link. There's a calculator where you can input how many hours of processors and what types you want, how much content, etc., and it gives you an estimate. So if you are using right now, I don't know, if you have a rack with 5 servers, with etc., you can copy that and see how much it would cost you to run the same, almost the same. Yes, that's the main office. It's not the only one. We have other big offices in New York or Chicago, Seattle, in Ireland and Switzerland, Australia, and all of those offices have different products. There's an engineering office in Brazil, in Belo Horizonte, but it's a small one, 120 engineers. So it depends on the product. Google Maps, for instance, it's mostly made in Mountain View and Australia. The Waze team stayed in Israel, so there's like 1,000 engineers there.
Google might mention the market series for us.
Mhm. Yeah. Yeah, exactly. That's a very interesting project. I love another option from Google that it's not only mapping, but they are doing the Art Institute. They are doing that for museums. It's the same technology. So now you can browse really cool collections of museums or typical art from different cities. That would be very cool to do here. Okay, yeah, keep it up. Ask me how you can work at Google or wherever you want. Okay, I'm going to move to the machine learning side of Google Cloud. And then we'll do one of the demos here with Cloud Vision. So this is going to be a machine learning 101 for those of you who already know about machine learning. This is going to be super fast because it's not the more technical or typical machine learning. Let me start with this video.
From the beginning, people have been tinkering, experimenting, taking things apart.
I think I'm missing this one. Sorry.
Trying things out, and when lots of people are able to get involved in this process, play around with tools and technology, it gets better for everyone. Recently, this has been happening with artificial intelligence, especially with machine learning. Lots of people are getting involved, exploring speech, language, image recognition, and more. And that work is being applied in helpful ways. In something like Google Photos, you can now just type dancing to find all your pictures of dancing. But if you're curious and want to play with this stuff, and you're poking around things like this, trying to understand how it all works, it can be pretty intimidating. That's why we've created a site called AI Experiments. It's a showcase for simple, hands-on experiments that show how machine learning can make sense of all kinds of things, like sound, language, music, live video, everyday objects, even in different languages, and your messy doodles.
I see flying hen or whale. Oh, I know. It's snowhead.
For each experiment, there's a simple video explainer by the people who made it. There are links to open source code to make it easier for others to make new experiments, and people can submit what they made. All of this is an effort to make this technology more accessible to everyone: engineers, hobbyists, students, anyone who's curious. This way, anyone can get inspired to start making things with machine learning. So come and start playing at g.co/AI experiments.
Okay, that was a small commercial because we would love to have some entries in that experiments site from the things that you can create, which is fairly easy to do. Let me just show you how easy. So I'm going to cover very quickly an introduction to machine learning, and then what are the APIs we have in Google Cloud for you to use. So historically, when we were doing with typical systems, we had this type of logic: if, else, while loops, for loops, etc. in the logic of the programming we were doing. But at some point, when the problems are really abstract and complex and different, we need to start dealing with image recognition, video, audio analysis, etc. And that gets tricky. If you intend to do it with the typical approach, it's going to be compute intensive. Results are going to be like very complicated to get and analyze. And that's a case for machine learning. The problem with AI and machine learning is that from the 60s, like from your parents, and the idea was that machine learning was coming and it was going to be like Terminator-like, very futuristic type of solutions, androids doing all of the heavy lifting, etc. In practice, it has never been that. It's never reached that potential. So for the longest time, we had machine learning and neural networks doing that type of work, but it was very mathematical. You needed a lot of infrastructure. It was doing at research facilities at different universities or very large corporations. So what we are doing at Google is putting all of that knowledge and all of that engineering that we have right now behind machine learning to be useful for everyone. And that's the idea. So for instance, if I ask you to classify this data set, and you have these two type of values, it could be fairly easy. You could do it with a simple if, then, etc. type of testing. Every point you can test if it correlates to one side or the other. But if I ask you to work on this data set, it's not as easy because the data values are all over the place. It's not easy if it's positive or negative. It's not as simple. It becomes much more complicated. You need a different type of analysis. And this is the type of problem where machine learning excels. It works very nice. So let me show you this demo. This is playground.tensorflow.org. TensorFlow is the name of the libraries and machine learning technology that Google released. It's on GitHub. It's open source. I will get you the links. But this one, it's a playground where you can go and use different types of data sets, decide how many layers you want on this neural network to analyze, and see the results. It's super easy. It's really a simplification of what you can really do with a neural network and what you can do with TensorFlow. But it can give you an idea of how this works. Let me, for instance, this is a typical neural network. You have different layers of neurons, a different number of neurons, and you can use this for classification or regression. It depends on what you have when you begin, what type of neural network you want to use. But let's say this is a typical problem, classification. I just want to decide whether this data is one kind or another. So if you start the iterations, you start seeing how it decides the world has like two possible values. You don't see very well the color. But if you start executing different iterations, so eventually you see how many is doing the neural network. The space, it doesn't get any clearer, but the color is progressing. It's getting darker and darker. And that means that it's already understood that with the data set it had for the training, it can create this very specific analysis. So the idea is once this network is trained with all of the data you have, you can present new cases, and it's going to be able to identify if it's yellow or blue in this case. You can add different layers, and it's going to be faster or no. It depends on again, kind of the problem. But you can see how fast it gets to the real solution. So that's it. That's the idea behind the machine learning in general. Simply to be able to present all of the data we have to the machine learning, to the neural network. The neural network, it's going to train on those samples until it gets it right with all of the sample data you have. And then you can present new cases. Typical use cases for neural networks in general have been, for instance, determining if somebody has cancer or no. We have 50 or so many years of treating cancer in different hospitals, so they have a data set, huge data set of people. This was the test, this was the results, and in the end, we know if the person had or didn't have cancer. So you can train with all of that data the neural network, and then when a new patient comes along, you take the sample from the blood, do the test, put it through the network, and the network is going to decide, yeah, this person has or not cancer. So that's the idea. A picture like that, you can ask if it's a cat or a dog, the little thing that it's sleeping in the clothes, and the neural network is going to decide it is a cat or it is a dog. That's the basic idea. So the first thing you need to decide if machine learning is a good idea for your problem is to understand what sort of decisions or output you want out of the neural network. The second is you need to identify you need for data and how many data you already have available, because you have to train the neural network. And that part is the tricky part. If you don't have enough data to train the neural network, it's not going to learn a lot. Right now we have a new type of machine learning. It's called deep learning. And actually it's super interesting. I was telling Antonio yesterday, one of the, I totally blew my mind. One of the experiments they created, they had this robotic arm, and they put 2 boxes. One was empty and one was full of stuff, different stuff, blocks, scissors, etc. It has a lot of objects in the box. And they put a neural network. The only things the program did was to control the fingers of the robotic arm, all of the servo motors to get the arm up, move it around, etc. That's everything it had to do. And they start recording the neural network, learning from scratch. And you see the neural network trying to pick up an object, and the object falls because it doesn't put the appropriate pressure, until eventually it starts grabbing the objects and it puts them up, and eventually it puts them on the other box. Sometimes it tries to grab an object, but it was on their other object. So it recognized that it has to move the object on top to the side and then pick this object and put it on the other box. Eventually, the neural network learned how to move all of the objects in one box to the other and neatly accommodate them in rows so that they use the less space possible. So that was pretty impressive because it didn't have any instructions. It didn't have a data set to train on. So it just learned to organize stuff on their own. Well, then once you have the data, you have to train the model, test the model, serve the model, and once the model is serving, then you can create software so that you can use it at scale. That's the basic idea. Let me show you a couple of tools and products we have to do that. Well, one you already saw a little bit with Firebase. It's almost the same idea. In Google Cloud Platform, you get access to servers, etc. Mobile Vision and TensorFlow, which is the library for machine learning that we released. So let me start with the Mobile Vision API. We are going to do a code lab with this API in a moment with Tonio. But basically, it has different APIs. The first one is Face API. It's already trained. You don't need to train these APIs. They already know how to do this stuff. So it can recognize faces, and if they are smiling, and where are the eyes, and the mouth, and the nose, and the ears, etc. There's a barcode API, a text API, and all of these three are very useful. In general, all of these APIs make more sense when you connect 2 or 3 of them, so that you can recognize text in one language and translate it to another language, for instance. You can see here the score that the neural network gives each face to recognize if the face is smiling or not. So you can see a 0.9 confidence. So the neural network is almost sure that this person is smiling. This is a 0.6 because it looks like he's smiling, but I'm not sure because I'm not seeing teeth, for instance. So smile 0.9, 0.8, etc. The idea is, for us, what we are doing with machine learning right now is we are lowering the bar that you need to use it effectively. That's the only issue. You just don't need to go from scratch creating the mathematical models, etc. There are other types of neural networks, but if you want classification, regression, the typical uses for machine learning, they are already there. They are already programmed. You just don't have to do that. And this is the basic idea. You can put the image through the detector and get the result. So it will give you a set of answers and the confidence the network has. In terms of code, it's not complete, but it's almost complete. The code you need to do this. For instance, recognize the face, recognize it. Actually, this code recognizes all of the faces in the video. It pictures selects the eyes, and then you can replace the eyes with these cartoon eyes. No? Things like the Snapchat or the things you can do with your friends when you are fooling around and you get your doggy ears and the mouth, etc. It's almost the same idea. It's not that complicated to do. If you do it from scratch, of course, it's going to be complicated because you have to train the network to recognize faces. Yes? Web API? Yes, of course. The API works for a lot of languages, so you can use it, different setups. The barcode detection, it works almost like you can see in the video. It's super fast. It recognizes one-dimension or two-dimensional barcodes. Text detection, this one is pretty cool. It used to be, OCR has advanced so much over the years, but it was done like, it was not a neural network-based algorithm. It used to be hard code, curve recognition. It was very complicated to get it right. Right now, it's almost perfect. If you have the text, even from a picture, if it's in a T-shirt, etc., it can get the text out of the image you are seeing, and then it can deconstruct the text in different parts. The paragraphs, the lines, the sentences, the words, etc. Yes?
So what's the difference between hard coding the recognition technology and using a neural network? What's the difference between the coding?
Basically, the difference, I'm going to say it's the speed and the potential. For instance, here, you can get the basic blocks just by dividing it for spaces. This is a word, etc. It's super simple. In terms of coding, it's not even that hard. But if I ask you, this word, what does it mean? It's a complete different program. Then you have to start doing a search or go to a dictionary, etc. Here, the neural network is like hyper-connected because you train it with a model, for instance, of the internet. So if it's English language, it's going to tell you, this is English, and this word, it's a proper noun, and this is a verb, etc. It's going to be more connected to...
So in that case, the data set that has to work with can be expanded or...
Exactly. Exactly. Actually, that's the way we are using it. For instance, for translation, we have a translation API and receives full sentences, and it gives you not the word-for-word translation, which could be fairly simple and easy to do, but probably not a very good translation. It gives you the idiomatic translation because it has seen that almost that sentence in another language, and it's used differently. So they give you the more appropriate translation. So in Google Cloud Platform, we have all of these tools, the hexagons I was telling you before. So we have the cloud machine learning, which is these neural networks, etc. the natural language API, which does this understanding of language, vision API, speech, and translate. All of these can work together very well. All of them have pre-trained models, so you don't have to train them. Google has been using all of the indexes we have of the internet, public internet, etc., to train this so they understand a lot of languages as they are used by the people in their different home languages, websites, etc. And we support all of the Google API client libraries, so you can use it pretty much everywhere. This is the first one, the natural language. It supports English, Spanish, and Japanese. I think more. And it recognizes this type of entities, people, places, things. So when you see the language, it already knows that you are talking about the President of the United States, not a word that it's Obama, which doesn't make much sense. It understands that you are referring to a certain person. So it can connect that type of things. It can analyze sentiment. So if you give the network a piece of text, for instance, a Twitter that you just collected, or somebody mentioned me on Twitter, you can pass that through the network and understand if the sentiment was good, if somebody was praising you or loving you, or it was hateful, that I want to kick you, and as soon as I see you on the street, I'm going to, etc. And it can also analyze syntax. Let me. Okay, this is not cool. So this is the Cloud Vision. It has, if you go to the site, cloud.google.com/natural-language, you can try the API here on the web. You can put whatever text you want. That's the text the web page loads with, but you can delete it and put there whatever you want, and then hit Analyze, and you will see the typical output for this program. Oh yeah, you have to let know that you are not a robot. That's a new type of CAPTCHA, actually, and it's smart. It knows that I'm not a robot just because the way I clicked the thingy. So you can see here all of the links and all of the words. As you can see here, it already knows that Google here is referring to an organization. Mountain View, it's a place, it's a location. Android, etc. are consumer goods. No, sorry, yeah, etc. So that classification comes just from understanding the language, because it has been trained to understand pretty much all of the text we have on the internet right now. So it's pretty amazing. The things you can get out of this are very, very useful. I was telling before that many politicians are using this in their campaigns, because if you imagine the number of times people mention Trump or Hillary or Clinton in conversations, in public forums, in blog posts, in Twitter, on Facebook, etc., it would be impossible to know if we are doing okay and if people is loving me more than the other guy, etc. So this is very useful if you have that many data points. Okay, the Vision API, it's almost the same idea. It gets the image, and it can deconstruct the image and recognize a lot of easy things like face detection. logo detection, label detection, etc. So you can take a picture of this room, and it will detect all of the faces in the room. If it can grab, or if the quality of the picture shows the names on the tags, it will detect the names. So you can put the name with the face, etc. This is super slow. I'm going to show the. Here also on the page, you can go. Actually, we are going to do one of these with Tonio. We are going to use this API so that you will use it in actual code. But here you can upload an image. And you get a response with the confidence the neural network has. And it says, it is a dog, 99% sure it is a dog. 97% it is a German Shepherd dog. It is a mammal with 94% accuracy, etc. So if this is really high accuracy, you can take that to the bank. It's probably true. This is used, for instance, I was telling you, if you have a blog, it used to be like, if you are very popular, usually what people do in companies, they hire a community manager. And the community manager is in charge of policing and monitoring all of the social accounts for the company or the person, etc. And then you put a post, and you see the comments. And if somebody is violent or nasty and puts a pornographic picture, for instance, then you have to delete it very fast so that the rest of the people doesn't see that. With this type of technology, what you can do is leave all the comments open, pass them through a filter that analyzes the picture, and if the picture is okay, I mean, if it's not porno, for instance, then you let it go. You don't need a person. You can very fast analyze a bunch of images. Okay. And the search API, this one is still on beta. It recognizes right now over 80 languages and variants. So the idea is that you can receive the content. You can actually, if you go to the site for the demo, it has a microphone button, so you can click it, start talking, and it will give you the text of whatever it is you're saying. So that's the basis for the Google Assistant and Google Home and all of these products, Android Wear, etc., where you talk to the gadget and instruct the gadget to do something. Open my calendar, add an appointment for tomorrow at, I don't know, at 7, etc. I didn't understand.
If you're using like the image recognition,
Yes.
You know, to create an application.
Yes.
Do you have to pay any royalties?
No.
Oh.
No, many of these have, since these are using Google's platform and it's compute intensive, you have a quota that is going to be free. But after that, you have to pay for the actual users. So if you have 1 million users of your app and you create 1 million image recognitions using our technology, you will have to pay for those 1 million operations. But no, you don't have to pay royalties. In a sense, you are paying for the Google Cloud infrastructure. Like if you were hiring the servers and doing your own stuff, it's almost like Google Maps or YouTube. You pay for accessing the videos or the maps, not the royalties for the service. Yeah, it's for actual usage of servers and memory, etc. Well, Translate API, as I mentioned, it's not a word-for-word translation. Right now, we are trying on doing the best translation possible for the language. If it was an idiomatic expression in one language, we want to give you the most common idiomatic expression in the other language, so that friendly. Yes.
When you include something like voice recognition in your app, you need to be online, of course, to actually connect the cloud service.
I'm not sure. Yeah, I'm going to say that some of these doesn't need to be online necessarily, but yeah, many of these are going to happen on the server side. But you can do image recognition on the actual hardware, on the phone, so you can even do it offline. Probably this one, it has to go to the servers, but in general, it's not necessary. So this is one example of usage. You are combining vision to take the picture, analyze the text, and then you use translation to translate the text you just read to a given language. That's a pretty neat idea. It's not that hard to do. Once you have the two applications, you can very easily connect the two to create this app. Okay, and then TensorFlow is the set of tools that were released. It's open sourced. The code, it's open. You can download it from GitHub. And it supports a lot of possible applications in mobile, Android, iOS, and even for Raspberry Pi, server, cloud, etc. It has Python and C++ APIs. And there's like two different types of users. One type is doing research, like in basic universities, large corporations that were already doing machine learning for research, and a lot of applications of people doing like the experiments I mentioned at the beginning. And that's the plan. So in general, what we are aiming is to give you all of these cloud products so that you can combine them as easily as possible to do really complex computations. It is just lowering that bar. You still have to do the gathering of the data, etc. But that's the plan. These are some other services. You don't need to do crazy stuff to use them. BigQuery is probably the most popular one. It can stream data at 100,000 lines per second. So you can upload tons and tons of information and have it analyzed in BigQuery and get you the results in a couple of seconds. The idea, for instance, is for data warehouses. It was typical for very large corporations. Imagine a bank. The bank has to, every day at closing hour, start a batch process to see how much money entered and was taken out of every account, add taxes or commissions, etc. Close the day, see how many of these accounts need to have their statement printed or sent by email, generate that, and send it. It was very compute intensive. And right now, they could do that on real time every second. As data starts flowing in, you can analyze it all the time and have each record for each account complete after the transaction was performed in one ATM, for instance. Or you could use it for these smart buildings where they are putting sensors everywhere, and they are recording every second the temperature, humidity, etc. You can collect all of that data, which if you have a couple of sensors, it's going to be very few. But if you have a couple thousand sensors, which is typical, you will get millions and millions of data points very quickly, very fast, and analyze all of that data. It's very complicated. Some of these products are very good for that. And so here are some of the use cases, typical use cases for structured or unstructured data. For instance, on the unstructured, which is the BigQuery examples I was giving you, call center log analysis, which is huge. If you imagine recording, if you call to one call center for whatever purposes, there's a recording telling you, this talk might be recorded for the quality purposes or whatever purposes, but who listens to those conversations, and when do they do it? Probably just when somebody complains or there was I don't know, something bad. But if you have all of those recordings, you can pass all of that data to machine learning and understand. If you are not understanding your users, you cannot improve your app. So every interaction your user have with your mobile site or your application, it's an opportunity to understand what they are using, when they are using it, why they are using the thing, how they did click on this, why they did it, why at that moment. You can start understanding and improving. So that's the basic idea behind machine learning, to learn what doesn't seem. This is just food for thought, and the idea is to leave that probably as a home project. So if you want to really dig into these technologies, it's a bookshelf application. Probably if you have over 50 books, right now you wish you have an app that could tell you how many books you have, where they are, if you lend the book, who you lend it to, and when the book is coming back, etc. But it's a pain. There's a lot of apps right now, Safari and many others that you could use. But if you could use these technologies, it would be super simple to take a picture of the book cover and to have it analyzed and see the title, author, etc. Or you can scan the barcode of the book. So you could do that with the Vision API. Recommendations. You could do a search and see, oh, this book was very good. What else is similar? And what other books should I get next? And you can use the other options. So I'm going to stop now and have Tonio walking you through the Vision API. And we are going to do another practical example. Does that sound good? OK. No, tú, dale.
Thank you. Hi again, guys. I will continue talking about machine learning, and Google is interested in see, hear, and understand the world. That's the reason to create this kind of services. Machine learning as a service. All of them are software as a service. You can start using machine learning. You can start using TensorFlow and create your own models, and then tuning using machine learning service. Vision to get the info about pictures, natural language, get the highlights about about that text, speech to transform an audio to text, and translate, but to translate languages. It's so obvious. And you can mix. Maybe I can start to speak in Spanish, and you can translate. You can convert my audio to text, and then pass it to Translate API and understand in real time my words. And what is machine learning? I think this GIF is great. It's great because machine learning is about that. It's create algorithms, train with data, and tuning with the machine goes wrong. Bad computer. You need fix the algorithm or improve your data set. Let me show this video. Paco was. This is similar to the GIF, but there is no violence here. ¿No suena?
Using 14 different robots, each equipped with 2 deep neural networks. The neural networks will lead to grabbing that packet. One will put a photo of it, whether the robot can grab the object. The other network evaluates how well the arm grabs it, and then those photos have to change the strategy. Research team has robots pick up ordinary objects 800,000 times. Untrained, they fail to pick things up for 3/4 of the time. Trained, that's where about 80%. I'm taking one of these next time and logging it.
Yeah. A lot of times to train. To train the robot. Many people says that the numbers recognition is the hello world for deep learning. You can implement using TensorFlow. You can implement numbers or image recognition in only 6 lines of code. That's what we see, what the computers see. And you can implement your custom algorithms. You must train with a lot of data, because I can draw a number in a number 1 with some extra lines. But the system must be able to recognize all kind of variations, all kind of numbers 1. You can recognize more complex entities like pets. But if you don't have enough time to implement your custom algorithms, you can use some Google Cloud APIs. You can go faster. Cloud Vision APIs let us identify or detect faces. You can identify emotions, facial landmarks. You can detect lips, eyes, the nose, and extra elements. You can identify many entities in a picture. For example, in this picture, you can recognize helmet, people, ships, the sea, towers. You can extract the text. You can identify the language, and Cloud Vision API will respond. The text is in this part of the image. You can identify logos, safe search to detect explicit content, adult, violent, medical, and spoof, and landmark and image properties. Maybe you can pass a picture of a very popular spot in Trinidad, and Google Cloud Vision API will respond with the name of that spot, the latitude, longitude, and you can get also the dominant colors of the images. How it works, how you can use this API is really simple to use. You only need 3 steps. The first is create a request. You need represent your image as JSON. You need convert your image in text, or you can include the URL pointing to an image. You can choose the image in text or the URL of the image. And then you need make a post request, including the image, and then Google Cloud Vision API will respond with the properties, and it's all. We will use first wait a minute. The pricing, you was asking for price. For 1 to 1,000 images over 1 month, it's free for all kind of detections. But if you need more, you will pay this quantity for each detection. And we will try again, just to show some vision. I love cats, and then I have pictures of cats, but that's the image. It's a truck in Mission Street in San Francisco. Google says color, art, graffiti, advertising, street art, poster, and mural. But Google doesn't say cats. Why? I'm not sure. That's because that's not a cat. This is a draw. This is street art about cats, and you can get text detection, and the Vision API is marking the the text in the image, you can get the info rating LCO 5, well, some numbers. The dominant colors. Safe search. Very unlikely, adult. And the response. The response is JSON. Always will respond a JSON with all the information. The label detection. The ID for knowledge graph. This ID is useful if you are using the knowledge graph. Description and the score for that label detection. The text. The vertices for ¿cómo se dice? Un cuerpo geométrico, ¿cómo se dice? Un polilíneas, no sé, olvídalo. The vertices, the points for vertices to identify where is the text, and in what language. Use the two letters code, English. And the colors, the sun. And let me try with another image. It's my cat. Right now it's cat, 98, small to medium sized cat, black cat, cat like mammal. And sometimes it's not perfect. Vision API is not perfect, but it's improving continuously, because in text, Vision API is responding there is text, but no, it's only a draw. It's a draw in the house of my parents. It's not text. You can identify faces. Phase 1 has its own results. The second phase, I'm happy, joy, or maybe joy. I'm enjoying. Labels. And safe search. Violence. Maybe the master is scared about me.
It's for the threat of...
Yeah. And the code lab, I will share the URL. To do this code lab, we need enable some services of Google with Ghost, and then in this time I will only do some part of the demo. Maybe you can repeat later. because you will need a credit card to activate some service. But I can show you. But before, this is an example to show the abilities for a neural network. This Google neural network is trying to identify our draws. It's a play. Please enter to quickdraw.withgoogle.com and let's draw. Someone wants draw in my computer for an sticker. I have a sticker about for Google. Yeah, you must the game will ask draw 6 things. You must be able to draw at least 3 things in a good way to let the neural network identify your draw. Yeah. Yeah, let's draw and start to. You draw stop under.
I see hockey stick, 4 suitcase. I see pillow, 4 postcards, 4 square, 4 birthday cake. I see dishwasher, 4 filler, 4 points, 4 bed. I see cake, 4 toaster, 4 passport. Oh, I know, it's 2.
Great. You need a leg.
Oh, I know, it's legs.
It's great.
I see bracelet, 4 headphones, 4 nails, 4 microphone. I see telephone. Oh, I know, it's pencil.
Yeah.
I see hockey puck, 4 pillow, 4 potato, 4 circle. I see watermelon, 4 clock. Oh, I know, it's fun.
The Mona Lisa.
I see toothpaste, 4 square. I see computer, 4 hospital, 4 passport, 4 dishwasher. I see lamp. I see keyboard, 4 pillow, 4 pool. I see pencil, 4 canoe, 4 toothbrush, 4 tape. I see laptop, 4 birthday, 4 napkin. I see food chips. I see tree boat. I see seesaw. I see pencil. I see jacket, 4 skateboard.
4, yeah, you won. Congrats. You're an artist. Yeah. Not the pencil. We have many kind of legs, many kind of pencil, ponds, just one Mona Lisa, and many kind of trains. Sometimes Google can recognize some draws, sometimes not. But Google is trying to identify patterns. The patterns is the useful way to try to identify what kind of thing is drawing Jonathan. Did you try? And let me show an extra video.
Cloud Vision provides powerful image analytics capabilities and easy-to-use APIs. It enables application developers to build understanding can send the images taken by its camera to the cloud and can get the analysis results in real time. It detects faces in the image along with the associated emotions. The Cloud Vision API is also able to detect entities within the image. Now, let's see how facial detection works. Cloud Vision detects faces on the picture and returns the positions of eyes, nose, and mouth. So, you can program the bot to follow the face. It also detects emotions such as joy, anger, surprise, and sorrow. So the bot can move towards silent faces or avoid anger or surprise face. One of the very interesting features of Cloud Vision API is the entity detection. That means it detects any object you like. See how it works. You see, Cloud Vision lets developers to take advantage of Google's latest machine learning technologies quite easily. Please go to cloud.google.com/vision to learn more.
And the second URL is for CodeLab. The first is for the draw with Google. The second B, yeah, is the CodeLab. The CodeLab will teach us about how to use Vision API with Node.js to create a web app, to upload images and then store in Google Cloud Storage, and then get the response and show that result in the web page, similar to this example. This? Sí. No me deja hacer esto, el puto Zoom. Maybe, sí.
Yeah, exactly.
Gracias, Paco. Yep. And this CodeLab will integrate Google Plus API to offer sign-in, cloud storage to store our images, and Cloud Vision API to detect some features of different image. And you will need Node.js, the package manager, the code, And maybe they suggest be familiar with BI, Emacs, or Nano, but I will show another tool of Google Cloud Console to avoid use those editors. The first step is create a project in Google Cloud Console. You can create your project for free, but you will need enable the $300 free trial to enable some features. But to enable the trial, you need a credit card. Yeah. And then we will use Google Cloud Shell. You can replicate this Colab also in your machines, but the building must be enabled to get the keys, and to get the API enabled. And then we will start. The first step is open the Google Cloud Shell. In the console of Google, when you create a project, just write console.cloud.google.com. This is the main dashboard with info about some features about Google App Engine, Google Compute Engine, info about your cloud storage buckets, some statistics, the list of your projects, one of them, and there is an icon in this corner. If you click, you will activate the Google Cloud Shell. The Google Cloud Shell is a Linux machine. You can use this Linux machine to run some commands. This machine has 5 gigas to persist some information, some data, and has installed Google Cloud SDK, Python, Node, and some useful Linux programs to run some commands and do some common tasks. Git is included, and yeah, you can use we are using this Linux machine in our web browser. You can use in any modern browser, Edge, Opera, Safari, Firefox, of course, Chrome. And then, if you have a Chromebook, you can write some code, programming, use all features of Google Cloud, the Google Cloud Platform, without install anything in your own machines. You can use the Cloud Shell. Then it's time to download the code. You just clone the repository. I already did. I have let's see. I have the repo. See cloud. I will use complete. In the repository, you have two directories, two main directories with code. To start your demo, you will find and replace some line, or complete is the whole code, and then you only need to modify some lines with the name of your project, your API keys. I have the code, the skeleton of my project, and it's time to install dependencies and run for first time the app. Yes, ese fue el warning que te apareció. Sí, ¿verdad? Yeah. I have installed dependencies, and right now I have a web app running from the Cloud Shell, but how can I access to this web app? Google Cloud Shell can help us using this web preview. In this site, you can click this little button, the web preview, and you can access to your app on the port 8080 or change the port. There are some extra possibilities. We will use the 8080. And right now we have this app. It's nothing is happening, and then we will need add some code. And you have a public URL to access to your web app. Now we need create a OAuth client ID to authorize the signing. We will use the Google Cloud console to create my keys. We need go to API Manager, credential, and create OAuth client, and then is the API Manager. Credentials, an API key, or OAuth, yeah. For web application, What's the authorized redirect URI? It's this. Callback. Yeah. And it's okay. You can add the JavaScript origin if you're planning use that feature. And Google will respond with my client ID and my secret client. We will use in a minute. I have my, you can administrate, manage your all OAuth2 client IDs. But right now, it's time to start to modify. The code lab will suggest using the nano editor because it's possible using the Cloud Shell. I will stop the app. You can edit, but sometimes it's not so easy or so comfortable edit our files using these useful but not so comfortable editors. Instead of that, we can use another feature of Google Cloud. We will use the editor. Google Cloud includes a new visual editor. You can use the launch code editor, and you can upload and download files to your 5 gigas storage, and then launch code editor. And again, you can edit, you can write code in your web browser. You don't need to install anything in your computer. And you can select your file. We must edit config.js, and then start config, and we must replace the client ID and the secret ID and the redirect URL to be able to use the project. The URL is the same. And my client secret, you can go to API Manager, select your OAuth client ID. No, it's here. What happened? Otra vez no. It's above the client ID. and your client secret. Right now, we are ready to implement the login, almost. And you can save your file. And you can continue. And it's more comfortable than use Nano. Now we will install the Google APIs and run again and modify the app.js to define to use some routers and start to show the name of the user when the user has been logged. The second part is enable the Google Cloud Storage to save your images. When you use App Engine, you get a default Google Cloud storage bucket to save the files related to Google App Engine application. For this Colab, we are not using App Engine, but we are using its default cloud storage bucket. And then we must go to App Engine, settings, and enable your cloud storage. Offers you for free 5 gigabytes to store whatever you want. Excuse me?
Does it support FTP in the Linux machine?
Sorry, I didn't understand. FTP?
Yeah.
No, you don't need activate FTP. Yeah. Are you planning to use FTP to upload?
Yeah, to edit the files instead of using FTP files.
You can open. You must open the some ports and authorize traffic over TCP protocol, and you can do that kind of things in where is networking. Networking. You must define a firewall rule to define a name, a description. It's for us a network. The IPs authorized and protocols and ports. And then you can use FTP. I think I forgot. I forgot install the API, the Google API. I forgot. Now you need modify the permissions for your Google Cloud Storage. You can use the storage utility, Google Storage utility, to set to modify the access control list. The access control list is the list responsible to manage the access to Google Cloud buckets. For this Colab, we will set all people can read this bucket. And now we need install the gCloud to access to some features for Google Storage, to take the image and upload to Cloud Storage service, and use Multer to can process multi-part files in Node.js. Now has a different name. Now is Google Cloud. And it's time again to update some config variables. Right now we must set the right name for project ID and the bucket name. My project ID is in the main dashboard. It's here. It's on a demo. I can copy. And the name of my bucket, it's the same, but I can review I have different buckets, but I will use this to store the images. And again, I will use the editor, the web editor, to replace the values. And we need to add the post method to can storage the image in cloud storage and can use the URL. When you storage some file in Google Cloud Storage, you can store only for some users, only for you, or you can share a public URL. We will need a public link. You can get the link using the API, or you can use the web UI to get the public link for some specific file. In this Colab, we will use the Node.js API to can manage the code. And again, we will modify the base file in views to show the form to upload the file, and in this case the image, and show the image. But we need enable Vision API. We can in this point we can storage images in Google Cloud storage, but we need process this image and get the info about the pictures using Vision API. Then we need create a API key to get access to Vision API. We need return to Vision to API manager. And credentials, create a credential, API key, you can restrict the key. This key has all permissions to do any kind of stuff in my Google account. But you can modify and authorize this key or this key to only has access to a specific API or to do some specific task. Maybe you will use this key to only read files in cloud storage. You can assign specific permissions, and you can use this key to write files in cloud storage and use Vision API. You can be so specific in your permissions. And I will need DNT Vision. And you can use the copy. And we need enable the API. We have an API key, but the API is not yet enabled. Then you can return to dashboard and use the button to enable API. You can search. We will search for Vision. And it's enabled. Just click the button if it's disabled. And you can return to config.js to set your API key, save, and we will continue. We need modify app.js to ask the petition, to ask the request to Google Vision API, and do the detection using the URL of our file storage in Google Cloud Storage. And we will process the response. And to render the response, we will modify again the base dot file in views, you can choose how many results are you interested to show, from 1 to 10, and you can choose the type of the different features available for Vision API. In this point, we must save. And no. I forgot to install some copy. Yeah. I think it's you can log in. What? Wow, the out client is not valid. I need to modify my config.js. The OAuth client. It's the same. OAuth. OAuth to callback, I think is. Client secret. Sorry, my fault. I was editing the config in the other project. Client secret. ID. my and my credential ID. Yeah, I think it's okay. And oh, your secret here? Config 24. What happened? Complete, no, yes. Session secret, yours, or yours. Config 24. There is a there is a little, if you remember, when you click the editor, say experimental, there is a little book in the editor, concatenate some lines. The problem is here. All the API key, the name of my pocket, and some values are in the same line. It's wrong. I need maybe nano is not so bad. And I need the original code, and I can I'm not sure if I have the project in my close project. Webster, no, maybe I can. Git. Yes. Complete. Excuse me, I cannot listen.
Information at the top of the next file on the server because into a copy to that one by mistake, so it shouldn't have been there. In the start folder, you're copying to there, by mistake in the beginning, so it shouldn't be there. You can copy it from there.
Yeah.
That's it, right? You can copy it from there.
Sorry. Is again. Maybe just replace. Your client ID. And my yeah, it lives, it's alive. You can choose your image. You can select the kind of analysis, maybe colors, submit. The response is the JSON, and you can show the image you upload, and you can return to Google storage and search in your bucket, and maybe I have today is 29, the picture of my 29, November 29. You can choose another image, Palacio, what's the landmark? Submit. This is a landmark analysis. The name of the spot, the score, 70.5%. The polygon, eso era la palabra de hace rato, que un polígono. The vertices for polygon, and this is a very popular spot in Mexico City. Is a Palacio de Bellas Artes, or Fine Arts Palace. Yeah. And you can get the lat and long for the spot. Maybe, do you have, someone can tell, could you tell me the name of a a popular spot in Trinidad. Could you spell it? Red. Oh, or you can write. Yeah. Sorry. TGA?
Yeah, that's THE.
What's the meaning of TG?
THE, sorry.
Yeah, yeah. Yeah. It's Katong. That's maybe I will save. Desktop. And where is? No. There is another, maybe another directory. Vision. The best one sticker.
Well, I've already been dabbling with PWAs, but what I didn't know was about app that was new to me, so I'm definitely going to look into trying to use that to speed up the app.
Well, give me a sense of what you're going to give us some concrete. Yeah, what you
Well, I have to be building an app for piemen.
For what?
For piemen. Pieman you see on the street.
Pieman?
Yeah.
Nice.
So it's actually up right now, pieman.online. This is more for a unique kind of thing because it's one pieman who's beyond campus. You never know when he's beyond campus. So you need people to vote, and they say, yeah, you're on campus, basically that. I'm trying to get push notifications up right now, but I want to see if I can include that.
Yeah, selling pies. That's nice, man.
Yeah.
Check it on pieman.online.
You can choose a sticker. It's polymer, yeah.
Let's hear some more. What you see, especially with the AI and the fair frame.
I have this magnet for.
It's a little bit different. In terms of, we have a greenhouse project that we're looking to put a camera in that can detect insects or moving objects using the machine learning. That would be a good application. Or to check weeds or something.
You're actually going to build something like that too, no? Nice. Very good. Yeah, thanks a lot.
Yeah.
Right now, for our final project, we working with a cell phone and tablet company, and they're managing the stock basically that they have in their business currently, in the inventory currently, and how we try to optimize their system. But the thing is, one thing we want to really implement is mobility in that, so that the manager himself, he'll be able to tell, okay, low stock at a particular point in time, or we owe this company so much and so much, or we owe this customer such and such items. Apart from that, with the machine learning and everything like that, what we want to really try to do is kind of give the person, the manager, an idea of trends that start to develop. So when people buy what item, the issues that people have with such and such item, and how it may affect how others buy it. And things like that. So that's one thing.
Yeah, sticker.
Anybody else?
Choose.
I mean, it's good to see that people are doing things now.
Polymer.
I'm happy to hear. But anybody who wasn't doing anything, who wants to do something now, I want to hear that. So somebody who was not doing any.
It's a magnet. Yeah. For the fridge. Yeah.
Has an idea that they can build now and they can want to share. Joseph.
So aspect this morning, I think I'll be doing some online menus for like restaurants and stuff like that. That people could even order stuff and actually know what your restaurant has available.
Uh-huh.
You know, bring in the seasoning, the cloud stuff to create different experiences that we haven't had in China before. The food that different items, like shopping, like well, it is a food aspect, or the food or something like that. So online, when the menu, you can choose the food or have it delivered to your house and stuff.
Yeah, you can use App Engine to create an app or the backend of a mobile app to create this kind of app. Yeah, and a few minutes ago, someone was asking for prices. It's in Spanish. Google Cloud. ¿Dónde está? Calculator.
How many have used Google Cloud anything so far?
actually use that.
Yeah. You?
Firebase itself.
Yeah, Firebase is Google product, but it's
It's a more.
yeah, it's diff. Yeah.
Agri-expense is an app on the Play Store for farmers to track their expenses.
Agri-expense, you said?
Yeah.
Agri-expense.
Yes. And Firebase is one of I worked on two of them. That's built by people in UAE. And SR Market is the one we recently pushed out with Kali to track down for promote small rural and trade.
Yeah, great. GCM. You can choose the product and if you are planning to use virtual machines or create a web app in App Engine, you can choose the product. You can choose the product and set some values. Maybe I want 10 instances with Red Hat Enterprise, with regular or the printable are cheaper, with 8 cores and 30 gigas of RAM. One local solid state drive. In the data center of Asia, the newest, the Japanese data center. I'm planning to use 24 hours per day, the 7 days of the week, and I can get an estimate for this configuration. You will pay 2,700, almost $2,800 per month. You can estimate or evaluate the cost, but remember it's only an estimate. The price could be the cost at the end of the month could be lower if you turn off some virtual machines, or could be higher if you add some extra features. Yeah. And maybe
What is the free threshold? Generally for that right now.
the free.
Yeah, there's a threshold in which you don't pay for when you put the app on. What's that threshold now?
When you said previously, if you use any image analysis app, if you use under 1,000 images, it's free.
Yeah.
1,000 a million, it'll be something like $1.50 or something on that.
For the vision.
One aspect.
Yeah. Not all products in Google Cloud have a free tier. Compute Engine has not free tier, but App Engine has a free tier. Some of machine learning, no. Vision API, yes. And another BigQuery has a free tier. Container Engine, no. Cloud Data Store do. There are many products. You can check the pricing for each product, and each product has different price for its different features. Yeah.
One question, like, you know, you can create apps to sell mobile apps and user can make money from mobile apps. Could you do the same thing with the cloud platform? Could a user create an application that could use Google Cloud and people can buy it?
Yeah, you can create a model like a software as a service. People will subscribe to your web app, or you can use in App Engine. For App Engine exists a possibility to enable a backend. You can use endpoints, Google Cloud endpoints. And you can define tokens for your different users. You can get metrics for Jonathan. Jonathan is using your API. You can get metrics, and you can send him a bill for use, and you can monitoring Andrea if she is using your app. Of course, you can. You must decide the way to monetize your app. Some people have web apps in App Engine, and they try to monetize using advertising. And other people choose another people try the subscription model, and you manage the tokens to get access to your platform. You can choose the right way to get money in your platform.
Any questions on the
this or YouTube or
can
this?
hear me now. So, any questions? Can you hear me?
Yeah, one of the most famous app created using Google Cloud Platform is right now is Snapchat. Snapchat it's using Google Cloud. They started using App Engine to auto-scaling, because at the beginning they only had a little team of engineers, and Google App Engine was the perfect solution because solves many problems about tuning, performance, response, auto-scalability. I think this is one of the most famous. Right now, Spotify is running. It's running in Google Cloud. Robio, the creators of Angry Birds, they used App Engine to deploy the web app version of the game. And Coca-Cola used App Engine a few years ago during Brazil World Cup to create a mobile and web app to let users send pictures celebrating the World Cup, and then Coca-Cola create a mosaic with this picture, and they choose App Engine again for scalability, because they were expecting a lot of users in world. And do you remember another so popular? Google Cloud. Yeah, there are some successful stories. Wix, Wix. Do you know? It's a platform to create websites in an easy way. Just drag and drop and customize the text. It's so popular. Spotify, Snapchat, Philips. And there are many clients. I'm not sure if the BBVA, the bank, and Spanish bank. It's an important bank in Spain, in Latin America, in Spanish-speaking countries. I think they are using some Google Cloud services to process data. And ¿quién? ¿Dónde estaba? Customer? Yeah. There are another. Of course, Evernote. Evernote is using Google machine learning services. They are using machine learning. Best Buy, Khan Academy. Khan Academy and Udacity. They are using App Engine and BigQuery. Avaya, Pizza, Domino's Pizza, and Shazam. Well, Shazam is using Firebase. It's using Google technologies. And there are many clients, but there are some of the most popular. Netflix use solutions in Amazon and Google Cloud. In Google Cloud, I think they are using Google Cloud Storage to store some files to stream the content of movies, TV shows, or another content. Yeah, there are many kind of clients. Be all customer. Feedly. Yeah, it's a popular mobile app. Motorola, Scalar. Genomics, using BigQuery and Google Genomics to analyze genomic data. There are many pages. Sony Music. Yeah. Do you will use? Yeah. 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 When you have a small quantity of devices, you can use data store to save some data and then make some analysis or integrate app engine, but if you are planning to use thousands of devices around the city, the country, to monitoring whatever you want, you can still use Google Cloud Services, but you can use BigQuery. BigQuery let you insert until 100,000 rows per second, or use Bigtable to insert a lot of information, and yeah, you can use many services of Google Cloud. And thank you, guys. That's all. If someone modify the first code lab, adding login for Facebook and Twitter, I will give you the license for JetBrains product. Maybe tomorrow I will. ¿Vamos a estar aquí mañana? ¿Sí? I will stay here tomorrow, and then if you modify the code lab and add login for Twitter and Facebook, I will the license for JetBrains.
Which IDE is it?
Which for code lab?
Which JetBrains? What does the license give you?
You can choose the product. Yeah, it's better. You can. It's a 100 discount for an IDE. You can choose JetBrains. IDEs. You can choose one of them. WebStorm, RubyMine, Rider, DataGriff for if you like databases is for you. CLion for C and C++ programmers, have code for iOS. IntelliJ for Java, developers, PHP Storm, of course, for PHP, PyCharm for Python, RubyMine for Ruby, developers, WebStorm for JavaScript. And you can for example, I choose IntelliJ, but you can download the plugin for PyCharm, and then you get both IDEs in the same product. And then you will choose. If you win, you will choose one of them for free. The price is, I think the price is around $100. Individual customer. Yeah, you will save almost $150. ¿Vas a cerrar con algo, Paco? ¿O no? Entonces, Tracy.
No. All right, everyone. So, thank you very much. Do you have any final questions for myself or for Paco or for Tony?
entirely sure what all of this is. You just told that Google was here and I just found myself there, so I'm not sure. But this is I just remember, I know it's an entrepreneurial thing with 2 days, and today was the technical one, and tomorrow was for the.
Alright, so, as I said,
and those minutes.
easiest thing to do is Google Global Services Promotion Program, and you'll see a lot of information there. So what we're trying to do. So, long story short, we are attempting to close the skills gap to ensure that employers and investors who are coming to Trinidad and Tobago don't complain that there are no skills. Simple as that. So that there's a increase in quantity as well as quality of the skills that are available in the sector. And as I said before, it's the ITeS sector. So it's not strictly software development, so we have to mind it's all something about IT-enabled services. And we are really working with all sectors. So don't think about yourself working only for software development firms or for IT firms, also for any firm who is doing IT-enabled services, banking, insurance, manufacturing, any of those services. So that these are the kind of things that we're trying to show you opportunities to you as